Oh yeah, maybe you just leave and join again.
Yes, okay, right.
Yeah, okay.
No, Lakshmiji, he asked for to put the poster, but anyway, there are 5-6 minutes left. We can start streaming. Or what else?
Shiromani Ja, madam.
Yeah, I'm just give me 1
Okay,
minute.
okay.
I'll share my presentation.
Okay, that's fine.
Swagat, I made it. I made it. I made it live. I made it live. You just check the channel.
Okay, just 1 minute.
Yeah.
I kept open it.
Yeah, Lakshmi, this is all right.
Yeah, this is all right. Just I need to mute only.
No, it's coming live.
Yeah, it is coming.
It is coming live. It is coming live.
No, please check that question under session. You are able to question something, or please check.
Yeah.
No, somebody sharing screen.
Yeah, that's
It's me. Can you see my presentation?
Yeah. Just presentation is not there, but share screen is there. Yeah, it is there.
Okay,
But,
okay.
No, Mohan, please check whether question and answers you are able to.
Yeah, we can do. I checked it.
Okay.
So my presentation is visible, right? I'll stop share, right?
No, Shiromani, this is not your presentation. It is something else which is
Really?
coming as a log of some events, screenshot.
Okay. Let me try again.
No, you need, sir. I can.
So Somesh, sir, live is going on.
Yeah. Good morning. Good morning, everybody.
Good morning,
Dr. Dash. Namaskar.
Good morning.
Morning. So many people have already joined. I hope all will join before the time. So, okay.
Somesh, sir, I think we can check the names whether at least first session people are there.
Yeah. I mean, whether everybody is present. Yeah, that's why I was trying to watch on the screen that who are.
You see the participants list.
Yeah. Well, I could see Dr. Rathod Sahab. Is Dr. Zahir Ahmad Babar from PMD, is he present?
Good morning, everyone. Yes, I'm here.
Good morning. Good morning. Yeah. Could you please switch on your video? I would like to see your face also, if possible.
Yeah, he did.
Sir, I'm just trying to share my presentation. Is it
Yeah,
okay?
I think now all right. Now all right.
Okay. Thank you so much, sir.
Yeah, now all right.
I would just like to call all the names one by one. Okay, yeah. Then I would like to see whether Colonel Sanjay Srivastava is already there. I hope he is there. Is Colonel Sanjay Srivastava present already or not? Not yet, it seems. Okay.
Only Abhay Srivastava is there.
Okay. Professor Sriram Sharma from Nepal. Are you there? Professor Sriram Sharma from Nepal. It seems he has not yet joined. Okay. Then Dr. Mazharul Aziz from Bangladesh. Are you there?
Yes, I'm here.
Yeah, he was here.
Yes,
He was here.
welcome. Could you please switch on your video? We would like to see you. Yeah, great. Thank you so much. Yeah, thank you. Then I would like to ensure whether Dr. K.R. Abhay Singha.
Yes, I am online. Something wrong in my camera.
Your camera is not on?
It is not working, he told you.
I see some problem with the camera. Okay, but you are there. Fine, good. And then I would like to ensure Dr. Karmakar. Are you there? Dr. Karmakar from Bangladesh.
He was here. Yeah.
fluctuating internet. Then Mr. Calvin Wu from Myanmar, are you there? Calvin Wu. Not yet.
Yes, was there
Yes.
for.
Oh, he was there.
Good
Okay.
morning.
Yeah, he's here. He's here.
So, yeah,
I can
great.
see. Yeah.
Okay, great. Yeah, yeah, good. Welcome. Then I'd like to call the name Dr. Pawar from IITM Pune. Dr. Pawar, are you there?
Yes, sir, he joined.
He joined? Okay.
Yeah, he already joined. Maybe he needs to unmute.
Okay. Then I can see Dr. Siromani Jayawardene from Sri Lanka. I could see.
Hello, I'm
Yeah,
here.
I could see you.
Good
Yeah,
to see you
welcome.
all. Yeah. Good
Yeah.
morning.
Good morning. Then
Sir, Sanjay Srivastava sir joined.
Good morning. Okay. So welcome, sir, Colonel Sanjay Srivastava.
Yeah. Also, it is 10 o'clock. We can start.
Yeah, we can start. I'm just trying to ensure all the speakers and chairs and co-chairs.
For the first session, I think yes.
Yeah, Dr. Abdul Mannan from Bangladesh. Are you there? Not yet. Dr. J.R. Kulkarni from IITM. Are you there? That okay. Then Professor Deepak Aryal from Nepal. I hope you are there. Professor Deepak Aryal. Not yet. Karma Dupchu.
No, he was here, sir. Deepak Karyal.
Oh, he was there. Okay.
You please check again.
From Bhutan. Are you there? Yeah, maybe if you have seen it is fine because internet keeps fluctuating, so people get disconnected. Dr. Soma Senroy, are you there? Dr. Soma Senroy from IMD, not yet. Okay, Mr. Malis Fernando from Sri Lanka. Mr. Malis Fernando, are you there? From Sri Lanka.
Sriram Sharma also joined.
Okay, fine. Mr. Javed Miandad from Dhaka University. Javed, are you there? No, not yet. Okay, hopefully they will all join in between. I could see Mr. Sunil Karyavasum from Sri Lanka, no problem. I can see, I think, Ahmad Rasid from Maldives. Then Mr. Naseem Muradi from Afghanistan, are you there?
පුතේ මගේ කැමරා එක වැඩ කරන්නේ මොකද කරන්නේ ඒකට?
Mr. Are you there? From Afghanistan? No, not yet. Okay. Then Miss Manju Subba from Bhutan. Are you there? Mr. Manju Subba from Bhutan.
Sir, not yet joined.
Not yet joined. Okay. Miss Tahumina Abdul Kareem from
Yes, sir.
Maldives.
Yeah, she is here. She joined already.
Welcome. Then I could see Kyolwin Wu. Then Mr. Vikas Nepal from DHM. Mr. Vikas Nepal, are you there?
Not yet, sir.
Okay, so maybe he is still joining. Then Chiranjeevi Betuwal, also from Nepal.
Yes, sir.
Okay, great. Mr. Jahir Ahmad from Pakistan already is there, of course, you could see. And then Ghulam Rasul Sahab from EC Mode, Dr. Ghulam Rasul Sahab from EC Mode.
He's there.
Okay,
I've
great.
seen.
So fine. So I think we can start, Tyagi sir. It's already 10 o'clock. So Tyagi sir, can we start?
Thank you, Professor Someshwar. We may start.
Yeah. I think we can start because it's already 10:04 and our program is quite tight.
Right. So without losing time, let me extend a warm welcome to all the participants on behalf of Sama and greetings on the Earth Day. The Earth Day is celebrated every year on 22nd of April. This year, we have decided to celebrate, keeping in focus the relevance and the importance of weather phenomena over South Asia, that is the lightning. Lightning in tropics is a major weather hazard and every second you find that there are 45 crashes taking. More than 24,000 people die in the tropics, of which 25 are from South Asia. This part, we conceived the theme for this year's Earth Day event as Lighting Resilient South Asia. In view of the significant developments which have taken place in the field of monitoring, prediction, and the communication of lightning hazards, we are now at a stage where we can cut down these mortalities to a great number. And it is heartening to see that there had been a good amount of work taking place already in the South Asian countries. We need to consolidate and take it forward. So idea was to bring all stakeholders together, whether they are the people from the observing platforms or from the prediction or communication and interacting with the state authorities, policymakers, and outreach initiatives. So we have put up this ambitious program on a short notice. And I am happy to say that because of the tiring efforts of our organizing committee, we have been able to now bring all stakeholders on a short notice. And I'm thankful to each one of you, especially AC members of all the countries, that for the first time we are having 100% participation from all the South Asian countries. It's a very heartening, I see, news for all of us in the organizing committee. You may know that the organizing committee has burnt midnight oil to put this program together on a short notice during a transition phase when one of the chief organizers, Professor Someshwar Das, was in the transition phase. He has completed his successful tenure at the Rajasthan Central University on 15th of April. And during this phase also, he continued to work hard along with all our EST members. So I'm happy that we are putting up today's webinar together, and we have speakers and participants from all countries. So this is a very, very, very positive and encouraging development for the Sama. We also have Dr. Colonel Sanjay Srivastava, who has been working as a one-man army with the state governments, civil society, and up to the farmer level to reduce the impact of lightnings, to minimize the death, and he has been able to bring out significant reductions. So he has been kindly agreed to share his experience. And I'm happy that similar initiatives are also taking place in Sri Lanka, Nepal, and other countries. So we should learn from each other and take it forward. This is the very holding webinar at the farmer level to reduce the impact of lightnings, to minimize the death, and he has been able to bring out significant reductions. So he has been kindly agreed to. Is there any time lag?
No, it seems some of them have already, I think, opened YouTube also. That voice is coming. So I request, to please mute your YouTube channels. Please.
No,
or
everybody
at least mute your mics so that will not be heard.
And he has been able to bring out significant reductions.
Yeah. I think PL and Raju sir should mute. Yes. Sir, you proceed, sir, please.
Okay. So without taking much time, I'm thankful to all chairs and co-chairs who have agreed to be part of this event on short notice. Also to the speakers and of course my colleagues in the organizing committee who have put up this show, audited. You know that the Sama as such has got no resources of its own. It is the voluntary support from my colleagues in the organizing committee that we are able to put up these webinars. So thank you to each one of you. And of course, we have a support from the AC members, wholehearted support from the AC members. They are our guiding lights, and their presence in this meeting also encourages us to take such steps forward. Idea is that we, the meteorological fraternity and our co-workers in the South Asian countries, we share our knowledge, expertise, and promote for the betterment of the society, the science of meteorology and its application. So once again, greetings on the Earth Day and welcome to this webinar. I know it is quite a jam-packed session, so please, we have got eminent speakers, so please enjoy this session. Your feedback is most welcome. To improve, we'll try to record these proceedings to make it available to the wider community. It is also being transmitted on YouTube, and it also will be available on YouTube channel. Once again, thank you to each one of you for joining us. Welcome.
Samir sir, you are muted.
Okay, am I audible now?
Yes, yes, you're audible.
Okay, thank you, Sahab, for the welcome remarks. Our today's keynote speaker is Colonel Sanjay Srivastava, and I would like to introduce him formally here. Colonel Sanjay Srivastava is the chairman of the Climate Resilient Observing System Promotion Council, CROPSI. Colonel Sanjay is an active climate and environmental related disaster risk management professional. He has been instrumental in bringing paradigm shift in disaster risk management from responsive to proactive management. He specializes in remote sensing, early warning and communication, with which he has revolutionized the DM setup in India. Lightning in India is the biggest killer as compared to other natural disasters. Colonel Sanjay has been instrumental in undertaking lightning and holds credit for his concept lightning detection, forecast, capacity building, and safe grid management system. He has been instrumental in creating lightning safe schools, hospitals, villages, and cities in many states of India. He is convener of Lightning Resilient India campaign and aims to reduce deaths by 80% in the next 3 years. The United Nations had facilitated him for his contribution at Geneva during Global DRR conference in May 2019. Colonel Sanjay also credited of setting up disaster management system in Jharkhand. His major achievements include single emergency number 112, lightning forecast and safe grid management system, crowd management systems, proactive dot management systems, etc. Colonel Sanjay, a war decorated veteran from Air Defense Branch of Armed Forces, has also worked with United Nations institutions like UNDP and other international bodies like FEMA, COICA, South Korea, etc. Colonel Sanjay is alumni of St. Xavier's College, Ranchi, Indian Institute of Management, Ahmedabad, Defense Institute of Advanced Technology, Pune, Berhampur University, II-9 Fire and Rescue Services, South Korea, etc. He is a prolific writer and specializes on strategic and real-time issues on climate change. Doordarshan, All India Radio, and Discovery Channel have made short documentaries on his exemplary work. He has 34 publications to his credit and is a key writer, speaker in media, is involved with scientific institutions and academia in research and teaching. So with this brief introduction, of course, he has a long list of achievements, which will take a lot of time to read through. But with this brief introduction, I would like to request Dr. Colonel Sanjay Srivastava to start his keynote address. Colonel Srivastava, please.
Good morning, sir. Can you hear me?
Yes.
Thank you so much, sir, for giving me this opportunity to speak at the South Asia Meteorology Association. I am indebted to AVM Dr. Tyagi and Professor Das, sir, for giving me this opportunity. And I take this a great opportunity to share our experiences I have a presentation. Can I share it, sir?
Please, yeah, please.
Can you see the presentation?
It's coming up, I hope.
Just see the half.
Half, yeah.
Yeah, just I'm making it now full.
Okay.
Yeah, now right.
Can you see it now?
Yep, yeah. Very
Yes.
well.
I just want to. So, webinar on lightning resilient South Asia. Due to paucity of time, and there are a number of topics which are being covered. So, where the topic is being covered, I'll rush fast, and at the same time, I would like to come on my presentation proper. If you see the slide, we have three important things. Lightning alert, we have a Damini app which reflects how the entire scientific knowledge of India has been showcased on one palm top app which entire country is getting. Second is the awareness, what to do, what not to do. The child standing under a tree when it is raining and it is crossed. So it is very important, and this picture I'll keep showing you, because in India, what we had observed in our experience, 70% people lose life because of this, and it has been a great success. So I'll keep repeating this center one. And mitigation, lightning protection device, it's very important when we go ahead. Our tagline is, when lightning roars, never stand under tree or outdoor. As we know, lightning is a global phenomena, and there is always 2 million lightning taking place anytime. And as we know, heat, moisture, convection, they are the basic necessity. As far as the reason is concerned, we all know global warming, heat, deforestation, depletion of water bodies, pollution, environmental degradation. It has brought down the whole system in a manner that climate extremities are rising, and so the lightning fatalities. The fatalities are 24,000 plus, and South Asia accounts for almost 25% of it. So the aim was to stop the death. And for this, who were the victims? Community. So our approach has been community centric. Coming on to lightning in South Asia, if you see the global map, here is the South Asia and here are the countries. These are the 8 countries: Afghanistan, Pakistan, India, Nepal, Bangladesh, Bhutan, Sri Lanka, and Maldives. This we had covered earlier. But before we proceed further, we must know the geography of our South Asian countries. In the tropic, the climate what we have, lightning is a major problem. But lightning is different in the Himalayan hills, it's different in the coastal areas, it's different in Sri Lanka, Bangladesh, it's different in Maldives, and it's different in Bhutan. So its seasonality, its geographical vulnerability has to be understood before designing a solution to it. If you see the climate change vulnerability index, you see here the South Asian countries. This complete ring of Himalayas and along the coastal line, all the states, it makes us most vulnerable. So we need to be very, very careful, because lightning is a localized phenomena. Seasonality is different, its timing is different. So our action has to be accordingly driven. We are lucky to have Professor Das with us. We had a program on storm for these countries which had started, and it had come out with wonderful findings. And our action in this is basically driven by this storm experiment project. Lightning, as we all know, simple theory, that we have the convection, the clouds go up, and there is friction among the various particles, ice particles, and there is charge, and the charge comes down when there is a conducting medium and it hits the highest ground. So basic understanding of lightning is very important, not for us, for the community. Unless they understand it, our effort will not be successful. As far as the lightning is concerned, we know it's cloud to cloud. or the one which comes to ground is cloud to ground. And types of lightning what we get is in the jungles, river basin, coastal, urban, semi-urban lightning. This is the urban lightning I am showing you. You see so many tall buildings are there. A large number of lightning is absorbed there. But I must tell you, in these cities, electrical losses are phenomenal and which are yet to be measured. Similarly, if you see the rural areas lightning, you can see the lightning rod coming down and then in the horizon it spreads. So it is very important that we must know lightning strikes you vertically and then spreads laterally. And this is the coastal area lightning. So these three types of lightning is very important for us to understand. And as far as the impact of lightning is concerned, we get loss of human and animals, we get loss of service, loss of cultural heritage, and economic loss. And if you see the impact, it is mainly electrocution. You see this human being, the difference between two legs, 9 kilowatt, 8 kilovolt. So this difference is called step voltage. And this step voltage is the one which causes the difference. Higher the step voltage, more is the severe is the impact of the current. And it affects your respiratory problem, ventilatory fibrillation, and cardiac fibrillation, and muscular contraction and burn. So it is important that you should avoid this step voltage. Lightning scenarios, we all know we need cumulonimbus cloud, light wind, thunderstorm, hailstorm, and there are dry lightning also. So besides physical phenomena, there are sometimes no indication in the atmosphere and you get lightning strike. I have just tabulated the early warning which are there in various countries. You see the US, it's a mixed network. There is the early warning has given a positive result. Despite 1.4 billion lightning strikes average, they have an average annual death 59. Similarly, Europe is almost 60. China is 450. India had 2,500, which we have been able to bring it down to 1,500, and we are further working on to it. Sri Lanka 0.9, almost 300 deaths. Sri Lanka has also brought it down quite a bit. Nepal, again, the deaths are in the range of 300 to 359. These data can change, but this is just a figure I'm trying to show that the early warning has made a difference. Similarly, Singapore is again a good country where despite 0.7 billion strike a year, their death is less because again, end-to-end action by Singapore. So the importance is early warning. And in early warning, you must know the disaster, lightning, because lightning is a disaster when you don't get time to react. So the nature has to be developed among citizens so that he responds spontaneously. It should immediately. It is not flood where you will get warning time. Similarly, detection should be based on parameters. When as a meteorologist or as a decision maker, you are setting up the system, you must go on the parameters. Forecast should be impact based, dissemination should be localized and in the local language, and response mechanism has to be developed, and do's and don'ts have to be widely publicized. So what do you get in lightning? Basically detect hotspots and convections. All the areas which are hotspot, summer hotspot, they are the one where lightning takes place more. Detect electric charge because this is the first thing which develops. Then the sound. Sound is 1 to 30 megahertz. Intercloud flashes 20 to 30 megahertz. This is very, very important. Detecting 20 to 30 megahertz. If you do not have a sensor which is detecting in this range, you're losing early warning time. Similarly, cloud to ground flashes, that is 1 to 10 megahertz. There is energy content, there is current 30 to 180 kiloampere. So these are the things which needs to be detected. And countries like Philippines, India, US, they have gone for a mixed system. These are the various lightning detection sensors which are available in the world. I have just tabulated it. Earth Networks is 1 to 12, Vaisala is 1 to 350, TOA is 1.5 to 400, and it is Baltic, which covers the complete range, 1 to 30 megahertz. So you should be justified while selecting your parameters. We know the cause. I have deliberated upon it. The Indian approach, what we have undertaken is the end-to-end approach. First, we conceived a program, Lightning Resilient India program, an end-to-end integrated solution, and it is a citizen science approach. And the first thing has been in the framework of Sendai SFDRR, understand the hazard. So we are making public understand the hazard, and we have lightning resilience strategy, which we have taken with the mapping of the hotspot, vulnerable population up to last mile, and we have gone on the vulnerable hutments. And this is the campaign which we are running, and our aim is to reduce death by 50% in next 3 years. And our approach is two-pronged. Death must stop immediately, and the climate change adaptation part. We are going for both, and we have a lightning early warning system in India. We know the natural instincts of lightning early warning, but we have a India Meteorological Department, which has a mix of radar, satellite, and various networks from Indian Space Research Organization also. And the complete thing is available through a web link, and anybody can see it. And we are getting 48 hours outlook time, 24 hours time, and nowcast, which is 2 to 3 hours. And these are the actions by SDMA, State Disaster Management Authority. In India, actually, India is a country of countries. And in 37 states, we have state disaster management authorities. And complete dissemination takes place through them. This is our app, which all South Asian country can download it. It is accessible, it's in English and Hindi, and it gives you 40 kilometers of warning. Similarly, we have Meghdut for farmers and Umang app, and we have a common alerting protocol for alerting people. And we have also come out how to operationalize the early warning. So these are the networks where all resources we are utilizing, and we have come out with an outdoor alerting system, which is low cost, indigenized, and is under trial, and we hope to complete the trial by 30th April. And we have a complete solution which we are giving. Our Prime Minister is also very concerned about it, and we have a complete program how we are taking it forward nationally, regional level, district level, academia, and through the civil societies. And these are the lightning in India. And this is a support, big technical support. We are giving it to the state governments and to the community in finalizing the program and taking the system to the last mile. This is the wind hazard map of India, and I can tell you that these are the hotspots we have mapped. So every state has been told about the hotspots. We have also come out with a complete study of lightning deaths in last 55 years. Every third death in India is due to lightning, and we are, we have sanitized people, and it has been taken up nicely. We have come out with our reports. And we have also gone on case study. Everything we are doing a case study and educating state governments. And our research, we have mapped the complete country. This is a 1-year mapping where you can see entire country is affected. We had 1.58 billion strike. This is the quarterly mapping what we have done. And we have graded the states that in which quarter, which part of India is getting lightning strikes. And then we have done it for grading of all the states. We have Odisha and Madhya Pradesh topping the list. And then we have done for each state vulnerability analysis, industry, tribal, conversion ratio, and seasonality. You can see mining, northeastern states. And the best part, you can see in complete thing that the seasonality of lightning, when you compare states, Meghalaya, Mizoram, the month-wise occurrence is different. So it is most important for all of us to know that whether it is South India, North India, the seasonality is different. And you can see here the comparative chart. It is showing different. So lightning is a localized phenomena. You got to work for your own state, and accordingly you have to plan. Similarly, we have gone on the timing wise, which part of day lightning strikes and which month. Similarly, we have gone on backcountry management. Which area is safe, like the hilltop is not safe, this water body is not safe, which are the safer areas, and we are educating rural population. Similarly, we have gone on the much micro level study where area wise which state is more. You can see Lakshadweep becomes highly vulnerable. Similarly, population vulnerability per 1,000 persons, Chandigarh and Delhi comes out to be highest, which was never thought of. So we have come out with lightning days, lightning resilience, and thunderstorm comparison. We have complete presentation by Dr. Soma Rao. She'll give on the early warning. Similarly, we have come on the origin, various seasons, why lightning is taking place. So these various western disturbances which are hitting the Nepal Tarai and hitting us. So anticyclonic storm in January, again supplemented by this. We have gone for identification of victims. Who are the victims? Whom to target? So it is a farmer, it is the children, it is a cattle grazer, it is a tribal population, it is the animals whom we have targeted, and we have come out on mitigation. Mitigation is something very important which we must do, and we must educate people. We have come out with affordable solutions for people. You can see this simple lightning solution which we are giving to farmers. They are using this local bamboo, cycle rim, and earthing it and using it. You can see the fields and farmers are doing it safely. Similarly, we have gone for, this is a West Bengal picture. This is a picture from Assam. So this is how we have made lightning safe city, lightning safe society, and capacity building is something very important part. Lightning that is avoidable. And we are using all natural, scientific and local information for the community and taking it to them. And we have gone on policy level changes, educating people, school, football ground, to the mythbuster. We are also trying to clear the myths, and based on our work, our Odisha is the state and Andhra is the state. They have reduced the deaths to more than 60%. That's why they were awarded Lightning Resilient India Award. Our aim is to take the early warning forward in aggressive manner in the language of the people, target vulnerable people, that is farmer, women, school children, cattle grazer, fishermen. Promotion to innovation and research. We have also come out with research and various climatology for the region, which is here, and we have recommendations for the states. The key takeaway from today, that risk mapping of lightning hotspot is most important. I again repeat, risk mapping of lightning hotspot is most important. Microzonation as per seasonality, timing, geographical location has to be done. Citizen-centric approach has to be there. Early warning should be a mix of observation systems. Don't waste your money. India has wonderful early warning system. You can use it, and I'm sure Government of India will be magnanimous enough to share this with me. Capacity building of community is important, and mitigation. A lot of work has been done in Sri Lanka and in India. This has to be replicated in rest of the state, and research and development should be part of it. That's all from my side, sir. Over to you in case any question is there.
Thank you very much, Colonel Srivastava Saab, for a very interesting talk on Lightning Resilient India campaign. Well, I know that there will be questions on that, but we are running tight of time. So I would like to request those who have any question to write the questions in the chat box, so that at the end we can take up the questions if possible. And we can also write down the name of the speaker to whom the question is addressed to. So with this, now we shall start with the technical sessions. Our first technical session is on lightning resilience. The co-chairs of the sessions are Dr. L.S. Rathore, is the former Director General of Meteorology, India Meteorological Department, and Dr. Zahir Ahmad Babar, Director of NWFC, PMD. The DG PMD is unavailable today, unfortunately. He has to go for some meeting. So we would like to request Dr. Rathore and Dr. Zahir Ahmad Babar to kindly co-chair this session. Dr. Rathore, please.
Thank you, Dr. Someshwar Das. I, along with Dr. Zahir, welcome you all to this very important session on lightning resilience, and congratulations to all of us for Mother Earth's Day. And let me give a different dimension of lightning. Actually, through lightning, the lightning salutes Mother Earth. And Mother Earth, as we know, that support all biota, the plant, and plant growth needs nitrogen, and all the proteins we consume are composed of nitrogen. So nitrogen is one of the basic element of our life, entire biota. And lightning adds nitrogen to the soil, to the Mother Earth. We know that atmosphere consists of about 78 point some percentage of nitrogen, but nitrogen in air is not in the available form, and the two atoms which are of nitrogen, airborne nitrogen molecules, are held very tightly, and nitrogen, to make nitrogen available, these atoms must be broken or separated. Since our bodies contain nitrogen, and the way our bodies normally get nitrogen is by eating plants and animals, and they in turn, the animals eat plants. So the plant absorbs nitrogen in soil, and when we eat plants, we get the nitrogen in the form that our bodies can consume, digest. And a plant cannot make use of nitrogen in the atmosphere. So fertilizer is the way we add nitrogen, and the maximum fertilizers which are consumed globally are nitrogenous fertilizer like urea, etc., etc. So the nitrogen in the atmosphere can be transformed into plant usable form by this lightning process. And each bolt of lightning carries electric energy that is powerful enough to break strong bonds of nitrogen molecules in the atmosphere. And once split, this atmospheric nitrogen atom quickly bond to the oxygen in atmosphere and forms nitrogen oxide. And a rough estimate of this fixation amounts to about 10 raised to the power 26 NO2 molecules per lightning streak. So it's a very huge amount. And NO2 dissolve in water, which is available in the form of water vapor and raindrops, and create nitric acid, which form nitrates, and the nitrate fall onto the earth as the raindrops, and really help not only plants but entire biota, including microbes. So that is the role of lightning in nitrogen fixation. I thought I give a different dimension. Dr. Sanjay has told us as to what are threat to us, and therefore we have to really take that as a necessary precaution, etc., etc. In this session, we have three very prominent speakers: Professor Sriram Sharma, who is from Tribhuvan University, Nepal, and Dr. Mazharul Aziz. He was earlier project director of Bangladesh Water Climate research project, which was funded by the World Bank. And the third speaker is Dr. K. Rathanayaka Abhayasinghe from University of Peradeniya, Sri Lanka. And I would request Dr. Jahir to take the session further. Thank you very much. Over to you, Dr. Jahir.
First of all, thank you very much, Professor Rathore, and all the participants, and particularly the management of South Asian Meteorological Association for giving me a chance to be a part of it. As Professor Rathore has given the positive aspect of the lightning, so now the first keynote speaker about how to mitigate from those lightnings, and the second one was how that lightning nature gives us the positive aspects. So I think we are short of time now, so maybe we can start with the first speaker, that is Professor Sriram Sharma from Nepal. So if it's okay, we can give the floor to him to start with the proceedings.
Yeah, thank you very much. And good morning from Kathmandu, Nepal. This is Sriram Sharma. Do you see my screen?
Yes.
Is it visible? Okay. Okay, I take this opportunity to thank...
Professor, you can make it full screen.
Okay. wasn't it? So
Okay.
for some reason. Okay. Yeah, thank you. I take this opportunity to.
Sir, excuse me, sir. Can you turn on your video?
Okay.
It will be better so that you know.
Maybe if there is a signal network problem. Okay, fine. Yeah.
Yeah. Yeah, thank you. Good morning again. And I take this opportunity to thank South Asian Meteorological Society or Association for giving me this opportunity to be a part of this program. As Professor in the earlier note mentioned, the Mother Nature's Day or Earth's Day. And also, I'm very, very grateful to you all for taking up this issue of lightning as a bigger threat to the region, not only the region, but also it's a global threat. But thank you very much for for conducting such a meaningful program at this particular stage where we have this pre-monsoon season already onset. As the co-chair introduced, I am from Trivandrum University and I have been chairing Lightning and Atmospheric Research Center Nepal, and also currently I am the chair of South Asian Lightning Network, and of course I am from Trivandrum University Department of Physics. We are a little bit, you are from, most of you are from meteorology and I am from physics. So we may a little bit differ in the approach. But let me start with how the SALNet. I'll speak today on behalf of South Asian Lightning Network, as it is the body or it is the network of scientists, engineers, and technocrats and other people who are working or engaged in the humanitarian organizations. Basically, this network was formed in Tripura, India in 2019 uh, uh, by or with the uh, roundtable conference. So from then, I was elected as a chairman, and I have been carrying it on. Though most of the programs we have been carrying or conducting these days online, but we have conducted few programs even physically. To the basic idea, basic objective of this network is to mitigate the lightning related hazards in the region. It's not only in Nepal, but also in the region. And the network consists of the members from India, Sri Lanka, Bangladesh, and Maldives, Bhutan, and so on. Unfortunately, we could not cover Pakistan as of now and Afghanistan, but we are many people from this region, and most of them are from India, and mostly working with the lightning and its different aspects. And the journey of formation of Solnet started long back in 2011 when we organized conference or symposium in Kathmandu, Nepal, in association with the NAM SNT Center, New Delhi, Non-Aligned Movement Countries Science and Technology Center, then chaired by Professor Arun Kulshrestha and supported by the government of Nepal, the then Prime Minister Honorable Jalnath Khanal, and a prominent figure from Sri Lanka, Professor Chandima Gomas, who has been working in this field for a few decades. And this was the beginning, and we had around 120 participants from 18 countries from around the globe, and basically these scientists were or participants were from lightning background. And as a result of this conference or symposium, we have some networks established around the across the globe. Basically, in African region, there is SLNet, African Center for Lightning Electromagnetics Network. Similarly, Zambian network, and so forth. And these centers have been uh, conducting various programs basically to mitigate the hazardous effects of lightning across the region. And now, to go to the fatalities, you might have recently seen this video as Colonel Saab just before mentioned about the lightning hazards under the tree. This is one of the cases, this is from Gurgaon, India. Recently happened, I think a month ago it was there. So this video was sent by a friend of mine from India. So I think it has gone viral, and it's a very recent event. And this is a very, very, you know, good example of to stay away from the tall trees while the thunderstorm is going on. And regarding the fatalities across this globe, as Colonel Sanjay Srivastav has mentioned, although we try to gather the statistics or demographies on lightning fatalities, incidents, it is very hard to get from around the globe, across the globe. It is only, I think, so far about 30 countries only are, I mean, they're making available these data, fatalities data. We can get the data from these countries. And rest of the countries, we don't get data. So the lightning fatality data or demography is very poor as of now. And also, if we look at the data, statistics from the available data, then you will find Malawi, the African country, is the one which shows the highest fatalities per million. But this data that was obtained is sometimes dubbed as fake data. So apart from that, if you look into the other countries, then we'll see the African countries are the most vulnerable countries in terms of lightning hazards, in terms of fatalities per million. And apart from that, those African countries, Swaziland and then South Africa and Zimbabwe, there stands Nepal, where you have 4 persons per million deaths due to lightning, and it is the highest fatalities among all the disaster that we have in Nepal. And of course, Nepal ranks well above Sri Lanka and India, and yes, other South Asian countries, even Bangladesh, in terms of population, uh, fatal per million population. Okay, and this is the lightning fatalities mapping, and these only from these countries the data are available, and for other countries it's very hard to get the white countries. We hardly get the data, so a large number of countries are still lacking fatalities data. And if you look at the fatalities from these statistics, you can see that most of the developed countries have the very less fatality rates, whereas the developing countries have a higher fatality rate. So this is a bigger challenge for the lightning hazard is the bigger challenge for the developing countries than the developed countries. This is a lightning mapping. We might have seen that the Central African country, in terms of lightning, we can divide the globe in three chimneys. One chimney is in the Central Africa, and then Central and south southern part of American continent, and then southeastern part of the Asia that goes along with this Indonesia and up to this Bay of Bengal. So in this region, Bay of Bengal region, we get the large number of lightning density, and then there is a jump to the Himalayan region or northern part, northwestern part of the Himalayan region is also a very prone region. So this is the lightning mapping where we have high lightning density even in South Asian countries. Then we have so many challenges. Of these challenges, mythology is the one. You know, up to now, even if you now go to the rural areas, then you'll find the people talking about different stories on lightning. And in as we have got it from our Hindu mythology that Lord Indra is the one who is responsible for punishing the people committing sin on earth by hurling this Vajra from his hand. Similarly, in Buddhism, there is a mythology where the Vajra is used to punish the people committing sin. Likewise, even in developed countries, they have different mythologies. Myths are there even today. They have mythologies even in the developed countries. But in developing countries, other kind of myths are there. Local myths are also there. You know, these are kind of cactus tree that people plant, especially in western part of Nepal. This culture is there. You know, cactus tree on the rooftop. They claim that they say that they save these cactus trees save the building from lightning. So these myths are still there, and as I'm sorry to show this, but I have to tell this story to disagree with the Colonel Sanjay Srivastav regarding this kind of material. This is kind of misconception. I think we should avoid this kind of gadgets that we should spread in the society that can save the people working the large paddy field. No, I don't think so. As a student of lightning, I cannot say that this is the right idea, even though it can consist of a metal ring and down conductor, but it's not the solution because this has its limitations. And there are very fanciful gadgets in the market that are another challenges. They claim that these kind of gadgets claim that they can save life up to about 2 kilometers, 3 kilometers, and so on. But they don't have any scientific basis so far. So unless we get the scientific basis, any experimental evidence, I think we should stop this kind of thing that claim that these gadgets can save lives. So sorry to say so, but this is the fact. I think we should avoid these kind of fraudulent things to be marketed in the and if you look at the building codes of India and even updated code in Nepal and developed countries, this kind of gadgets, particularly called ESE, early stream emission devices, or DS, dissipation array system, and so, that claim that lightning can be absorbed or dissipated or whatever, are not accepted. These building codes don't accept these kind of gadgets that is being and that are normally normally, these codes are defining or declaring these kind of products as fraudulent products, as they don't have any scientific basis so far. So unless we get the scientific basis, we cannot accept this kind of materials to be marketed in our and once these are French technology, and these technologies are not accepted in the developed countries like US and UK and all these Germany and all these countries. So they
So
have some.
Sharma, for the time limitations, you have to be
Yes,
little brief.
yes, I'll get through it quickly. And then another challenge is this, we have very unsafe shelters, even though we have the shelters, but these are not safe shelters in terms of lightning. And then we have outdoor activity. Most of the developing countries have this kind of activities. So these are more vulnerable areas where people get affected. And then lack of awareness, we lack rigorous awareness. Even though we do the meetings and workshops, these are mostly limited to the hotels and so on. So we need to go to the society and raise the awareness in that part. And the lack of demography, as I showed already, that all these countries don't have demography. So, and also lightning detection network, we don't have even in Nepal, although we have detection network, but is most of the time defunct and so on. And I see one of the person, Mr. Bedwal, is from meteorological department, who is responsible for this, and he is asking if there is an alternative solution, because we have really lacking this kind of information. So I think we need to have some reliable kind of detection network in the region and developing countries, and preparedness from the government side. There is no strict policy for lightning, and even in most of the countries, they don't have lightning protection system in the building codes along with the electrical code and so on. So, and now even these codes are there in most of the codes. Nepal is lacking, so we have already upgraded, but it's not implemented yet. India has recently incorporated lightning protection system into 2016, and Sri Lanka has had quite long back, I think 2011 or so, they have implemented, but in Bangladesh and Bhutan, it's yet to be incorporated in building codes. So, and also another challenge is sporadic nature, that lightning can kill anywhere, and it's not a mass kind of killing. So this is another challenge, to have a compact type of warning system or a protection system. So these are the challenges we are facing. And as I am limited with the time, so I would like to, you can watch one of the video in the link given here. I can share it in the share chat box, so that everybody can watch. This is the video we have prepared to raise the awareness in the rural areas particularly. So with this, I would like to thank you again, and I'd like to stop my presentation right here. Thank you.
Dr. Jahir.
Yeah, thank you very much, Dr. Shriram Sharma from Nepal. It was a wonderful talk, and maybe if the participants have some questions, they can ask in the chat box, because we are running short of time and we have got a whole long day, full day ahead. So if Professor Rathore can agree with me, we can move on to the next speaker. And if you have some comments, maybe you can add to it. Over to sir.
No, thank you. Please proceed. I think we don't have time for questions, though there will be very large number of questions, and we can straight away invite Mazhar Bhai from Dhaka.
Hello, sir.
Dr. Mazhar, you have the floor. Kindly proceed.
Okay, thank you, sir. Good morning to everybody. I am Mazharul Aziz. I work for Department of Agricultural Extension. Basically, myself and Dr. Navangshu, both of us was co-worker of Component C of Bangladesh Weather and Climate Services Regional Project. So, and both of us jointly developed this presentation according to our past experience in working with BWCSRP. So, my topics, the outline of the presentation will be the present status of lightning in Bangladesh, proactive initiatives by the government, and present initiatives to control losses of lightning through operational agromet advisory service. Future strategies to strengthen the agromet advisories on lightning, conclusion, and way forward. So the preamble is that lightning is an extremely common weather phenomenon in Bangladesh. And while the common occurrence, lightning poses a deadly threat. Over past decade, lightning strikes have accounted many deaths throughout Bangladesh. And often victims are caught by surprise with little warning and no time to seek safety. Next, please. And this is the basic things of or the basic picture of our agriculture sector in Bangladesh. And by the way, I will emphasize or morely acquainted with my agriculture sector. You know, when lightning occurs, generally it occurs early in the morning and early in the evening, and it is mostly frequent in the May, and basically it is in pre-monsoon season when our main boro crop is that stage of harvesting. So every harvesting operation and also the cattle graze in the fields are all open. There is no shelter for them, both for the farmers and also for the cattle. So in my in the left hand side downside, there is the data of from 2011 to 2017 number of deaths due to lightning. So this is the activities and locations of fatalities due to lightning from 2000 to 2017. You see from that table that 36.4% fatality occurrence is with the farming community. Next, please. And this is the present status. That is the age range, and also district-wise the lightning occurrence. This figures they're developed from a conference paper, and this is also next, please. And this is also the average annual number of lightning death. That is, you see the most of the death or fatality occurrence held in the month of May and June. So this is the pre-monsoon season, and May and June is the month of harvesting our main paddy of boro. And the next chart you will see from 1985 to 2020, the number of fatality is rising. So proactive initiatives by the government. In May 2016, government of Bangladesh declared lightning as a disaster, and also the amendment of standing orders on disaster was amended by the Department of Disaster Management and Institute of Disaster Management and Vulnerability Studies, University of Dhaka arranged a workshop. This is the panel came up with two effective ways, that is non-structural and structural. The structural way is using by lightning arrestor, and non-structural way is to create awareness to people to create awareness among the people, like avoid tall trees, open fields, and boating, fishing. These are the things we can aware the people. Next, please. So it has been undertaken, an attempt was undertaken by Agrometeorological Information Systems Development Project, where I worked earlier under the component C of Bangladesh Weather and Climate Services Regional Project funded by the World Bank. And it is implemented by the Department of Agricultural Extension and with the collaboration of BMD and Bangladesh Water Development Board. And we are providing early warning to the rural farmers in Bangladesh of impeding extreme events, including lightning, though it is not frequent or the actual time-led advisories, but we are trying to work on it. Next. So this is the portal. Presently, Dr. Mohammad Shah Kamal Khan, he is the project director of the project, and he is doing well with the advisory services, including district, national, and other special alerts also. Next, please. So this is a screenshot of our National Agriculture Advisory Service Bulletin. And the next one, sorry, the next please. And this is the district level agreement advisory bulletin. This we issue twice in a week for all 64 districts of Bangladesh. The advisory services in agricultural sectors, like including the poultry, fisheries, and livestock. And we issue once in a week. And also we issue special agromet advisories. Lastly, we in time of Amphan, we issued on 16th May, and it was updated on 18th May, and the landfall was on 20th May. So we did it in considering a lead time. So it was 4 days lead time for the farmers of the Amphan affected areas. Next, please. And advisories, we generally provide advisories, and like keep animals away from open water pond. If the farmers are in the field and can't find any shelter, avoid tallest object in that area. And these are the advisories we are providing for the farmers based on BMB's weather forecast. And also government is taking initiative to plant palm trees, though it is a long-term idea, because you know that a palm tree reaches its highest growth by 40 years. So and also the right hand side, the below picture is trying with some arrestor, lightning arrestor in the field. But these things are, it is not, I think that it is time demanding. So as I told you earlier, through BAMIS portal and BAMIS project, we have a very robust and very dynamic message dissemination system through our control room of Department of Agriculture Extension, and we are connected with the district offices and also Upazila offices, with the kiosks, and with the sub-assistant agriculture officers, and also we have the farmers in our database. Next slide, please. So this is the database of our 30,000 lead farmers. They have been chosen from 15,000 farmer-based organization. We choose two lead farmers from each group, and we have a database of 30,000 lead farmers. They are supposed to send the or disseminate the message to the farmers. Next, please. And this is the picture of kind of short SMS that are conveyed to the farmers and also to our extension officials. Next slide, please. And this is the picture of kiosks. It is connected with the BAMIS portal and also the portals like BMD and Water Development Board, and they show the real-time advisories, and also in case of disseminating. This is another picture of Union Parishad. We have installed the weather boards there, and in case of any kind of emergency situation, and there is a place to write the advisories. Next slide, please. And also we have some, you know, in Bangladesh, we have a lot of channels, and also we have the radio services, and we are proposing with the project that with the componency of BWCSFP project that will be installing 12 community radios. And now future scenarios, future strategies, and this is the salient feature of the initiative, that early warning system based on total lightning detection in Bangladesh, and we'll be going to procure this system with the approval of our revised DPP, and our present project director, he will be in charge of procuring this early warning system based on total lightning detection in Bangladesh. And it will be science based, and there will be lightning detectors or sensors, and the data from the lightning detectors will be collected from integrated and integrated at the outside data logger and observed and predict. And also we are trying to from those that procurement, we are trying to establish a similar system like the state of Karnataka, Odisha, Maharashtra, and other states in India. So the proposed system will provide alert polygons in a specific software. Area-specific warning messages will be generated based on the probable area of lightning. I would like to say that we have heard that in India, it is a system of getting alert messages or early warning 40 minutes earlier with the 20-kilometer resolution. So the lightning mitigation strategy, the lightning detection system, and it should be installed. Dissemination mechanism, though I like to say that we have a very robust dissemination mechanism, and also automatic outdoor alert system and awareness activities we should take. So in conclusion, the farmers must be provided with timely weather warnings and adaptation measures. I will not go through all, especially DAU to roll out lighting sensitization and public awareness programs in collaboration with BMD to help vulnerable farming communities. And also we would like to suggest that because if you see the area of how where the boro is the main crop, and there's thousands of hectares of bare land. So we should, and if you disseminate the early warning with the 40 minutes lead time, but it will not be sufficient for a farmer to get a shelter. So we'll be recommending to install shelter throughout the country. And proper weather forecasting and warning system should be installed, and proper information about the lightning hazard precautions, preventive measures, and awareness should be disseminated, as some believe in myths. Some people do not know what are the proper action need to take before, during, and after lightning occurrence. So thank you everybody for your patient hearing. Thank you.
Thank you very much, Dr. Mazharul Aziz Sahab, for a very nice presentation. Now may I request Dr. Rathore to take the proceedings from here on, sir.
Thank you, Dr. Jahir. And our next speaker is Professor Ratnayake Abhaysinghe, and I straightway invite him for his presentation. You have the floor, Professor Abhaysinghe.
Good morning, everybody. And this is my presentation. And I am K.R. Abhaysinghe, visiting lecturer in Peradeniya University and former director of meteorology. And my presentation is on timely protection of life and property against lightning. Can you hear me?
Yes, we are able to hear you and see the screen, and you kindly make it full screen.
Right. Okay. Is it okay now?
Not yet. Full screen is
down
not
right
there.
side, down right side, and click on the full screen.
Sir, there is a cup. In the below there is a cup. You just down, down,
Or
down.
put F5 or put F5.
F5 or yeah.
F5 is okay. F5.
I can't.
Put F5, sir.
Is it okay now?
No.
It's all right. You can proceed. There's not
Right.
a big issue.
So may I have a short introduction about lightning? An average current of ground flash of lightning is between 25,000 and 30,000 amperes. Potential difference of a cumulonimbus cloud is about 100 million volts, and the energy of a lightning flash being about 5 coulomb is about 500 million joules, and dissipate in about
Not visible in full screen. Please go below and 71% before a cup. Click here.
Yes,
Yes, sir. Okay, thank you, sir.
Yes. And I will go ahead. And actually, lightning is a natural phenomenon, but it causes death and damage all over the globe. Among the disasters, failure of telephone systems, communication system, and computer systems are very common in all the countries. A remarkable number of buildings and trees are damaged due to fire caused by lightning. And this is actually this is concerned only about the ground flashes, which are the discharge between the cloud base and the earth, not about other lightning flashes. And lightning can reach a point or a part different ways, like direct hit, side flash, and contact potential, and step voltage, and the surge transfers. Actually, surges are very important because these are the high voltages induced in conductive particles, and they may travel to inside of houses and buildings, causing significant damages. Those are surges. And every country, of course, reports these incidents in their media. The latest example from Sri Lanka, 18th April, last Sunday, paper said 10 dead within 3 days due to adverse weather conditions, including lightning. So these reports are very common every year. 30 or 40 reports are can be read in the newspapers, and these are the damages done caused by lightning. And in this right hand side pictures, in all the places, at least one person has been killed by lightning. That is due to a secondary effect of the direct lightning. And these are some examples from media from India. Actually, in Bihar area in 2019, one day reported 30 people have been killed by lightning. And again in 2020, about 90 people again in Bihar, and 90 people have been killed by lightning. So many people have been affected. So therefore, the lightning is disaster. So therefore, there are mitigatory steps, precautionary steps to be followed by the people for mitigation of the lightning disasters. These are some of them actually. In environments with thunderstorms, keep electrical instruments disconnected from the main supply line, and television antennas should be disconnected from the television sets. Avoid handling, touching electrical instruments. Find shelter in a safe place to avoid exposing yourself to the atmosphere. Try to avoid loitering in open areas. Do not seek shelter under or near isolated tall trees and high grounds. By sitting down, reduce the effective height of the body. If in an open boat, keep a low profile. Avoid riding horses or bicycles, or riding in any open vehicles such as tractors. Avoid swimming or wading. Avoid touching or standing close to tall metal structures and wire fences, etc. Limit the use of telephones when a thunderstorm is overhead. Actually, here, of course, I have to stress that this is meant for a cable telephone, not for the mobile telephones. So these are only some of the precautions. There are many precautions like that. So these are called Faraday cages actually, completely made of steel or metal, which are very safe inside during the thunderstorm time. But on the other hand, these are all unsafe modes. So wherever you are open to the atmosphere, you are in unsafe position. So this is a very critical situation when one person happen to be under an active thunderstorm is very critical, because quickly lightning can strike the person. So in that case, normally you feel physically you feel this instant. So there is no time to go to a safer place. Only possible precaution is to sit down as far as possible. Quickly sit down, keeping your head lower and keeping the legs together each other. So that is the only possible precautionary step to be taken. So the first aid is also very important, because people normally know always they are not killed by lightning, but sometimes they fall unconscious, or they are wounded, or they are paralyzed. Because in this case, first aid is the first thing. So there are some recommended one. Body should be massaged, and artificial respiration should be given, and see whether the man can be recovered. Or only after giving the first aid only, they have to call for a medical treatment or call a doctor. So then, of course, let us talk about the protection of the buildings and structures. So in this case, of course, I have to stress this television antennas, because it's very common disaster in especially Asian countries, because people don't care about the protection of the antenna post. If there is no protection given to the television antennas, lightning is attracted by the antenna, then of course it will be conducted to the television machine, and there will be a very big disaster inside the houses. So for protection, of course, all the antenna posts must be properly earthed. That's a must. Then it's safe. And buildings with concrete steps are also very vulnerable, because concrete means there is some reinforced metal inside the concrete, which are attracting lightning. So once the metal attracted the lightning has to go to the earth through the people who are living in the house or through other property. So there will be a significant damage if this building construction is not done properly with conductive material and the earthing system. So this is another very common problem especially in Asian countries, because the religious structures, normally people build them at very high altitudes, and almost all these religious things have some metal parts made of copper or brass on top of the structure, which are attracting lightning. So when lightning is struck the top part, it has to go to the earth through the other part of the structure, causing a lot of disaster, a lot of damage. So these are some of the mitigatory activities or mitigations or protective actions recommended. Almost all the houses have a power supply now, main power supply. Unless the main power supply is protected with a very good earth circuit, the house is not protected. Therefore, there should be a very good earth system, earth circuit, and it is recommended that the earth resistance of the earth rod should be less than 10 ohms. So we have to maintain that very low resistance of the electric earth of the house or a building. Or other recommended one is the instead of one earth, better to have a number of earth rods or earth circuits around the building, and all the earth circuits must be connected with a good conductor like copper tapes or aluminum tapes. And again the resistance of the earth circuit must be kept at very low levels. It should be maintained at a very low level, like 10 ohms or less. So this is a Faraday cage. Always in physics we learn that Faraday cage means if there is any excess or extra charge or current contacts in Faraday cage, it will conduct very quickly, and ultimately the extra charges will be grounded to the earth. So inside is very safe. So if you can make a house or a building a Faraday cage, then of course inside is protected. normally the best thing is the lightning rod or lightning arrestor, which composed of three main particles: air terminal, down conductor, and earth terminals. Normally they are prepared with copper tapes or aluminum tapes, depending on the conductivity. And what happens in a thunderstorm, the air terminals are very highly conductive, therefore they attract all the lightning discharge in the vicinity, and the lightning current will be discharged to the ground depending on the resistance of the earth terminal. Therefore, whether it is a lightning conductor or lightning arrestor, you have to maintain the resistance of the earth terminal at very low level, like 5 ohms. Then whole building is
Professor,
protected
for
from.
time consideration, I request you to
Yes, I will take only 2 minutes more. So all tall structures, including religious structures, must be protected with lightning arresters, so lightning conductors. So lightning conductors alone cannot protect the houses because there can be some surges coming from outside. Therefore, in addition to the lightning rod, surge diverters, there are plenty in the market. There are so many categories. All type of surge diverters has to be used in the power circuit in houses. Then of course the surges are also surge diverters. Surges will be diverted to the earth. So if you use all these, both these say gadgets, lightning arrestor, lightning conductor, and the surge diverters, all the lightning coming from outside, direct or indirectly, will be sent to the ground, protecting the whole building. So that is how the structures are protected against lightning. So thank you very much. I had a very fast talking. Thank you very much.
Sir, your mic is mute, Dr. Rathore.
I'm sorry. Thank you very much. And for the time constraint, we will request all of you to seek clarification for your questions through chat box or through contacting the speakers by different modes. And we take this opportunity to thank all the three eminent speakers who gave a very good kaleidoscopic view of the lightning resilience in Nepal, Bangladesh, and Sri Lanka. So along with co-chair Dr. Jahir, I thank organizers to give opportunity to both of us to conduct this session. Thank you very much, and over to you, organizers.
Thank you very much, Dr. Athor Saab and Dr. Jahir Ahmad Babar Saab for smoothly conducting this session. I know we are running tight of the time. We are running about 15 minutes behind the schedule. And so we are not able to ask the question live, but I can see that very live chatting is going on about the questions and answers in the chat boxes. So please continue writing your questions in the chat box, and I would like to request also the speakers to kindly watch the chat box and reply if possible on the chat box itself. So thank you very much once again, the co-chairs, Dr. Rathore and Dr. Zahir Ahmad Baba. We are now going to start the next session, that is on lightning climatology. The co-chairs of this session are Dr. Samarendra Karmakar, former Director General of Bangladesh Meteorological Department, and Mr. Kyol Win Woo of Department of Meteorology and Hydrology, Myanmar. So over to you, Dr. Karmakar and Dr. Kyol Win Woo, please.
Thank you, Dr. Dash, and thanks also to the organizers to give me a chance to chair the session. And I have also co-chair Mr. Dr. O, perhaps from Myanmar. I met him perhaps in India sometime. I thank him also to be with me. So as we are already, late, we should not talk so much. But one thing is that lightning, as Dr. Rathore told, how the fixation is made due to the lightning. So lightning is essential for the fixation of nitrogen in the earth. At the same time, it kills a lot of people almost every year. And Bangladesh, I think lightning death is about 200 to 300 every year. So in this respect, I think proper preparedness. Do you hear me?
Yeah, you're audible. Yes.
Proper preparedness and management is very much essential. And also, in our session, the climatology of lightning will be discussed, and this is also very important where the lightning happens more. Today morning, I was listening one news that in the northeastern part, where maximum thunderstorm occurs in Bangladesh, already on the basis of the forecast by BMD, DAE already gave the instruction to harvest the paddy, and already harvesting is started because uh, lightning is going to be there and a lot of thunderstorms activity will be there, and maybe sometimes flash flood occurs there also. So that part, the northeastern part, is very, very, what we call affected by flash flood. So in our session, I think we have 4 papers. I wish to request Dr. O also to conduct the session partly with me. So I am giving it to Dr. O. Hello?
Hello?
Yeah.
Can you hear?
Yes, yes. Yeah, please, yeah.
Thank you, Professor Dr. Sanshawa and Professor Ajit. Good afternoon, everybody. I would like to be sincerely thanks to you for inviting this important meeting. Lighting cost standard energy from the lighting channel heat to air briefly around 50,000 degrees Fahrenheit, much hotter than the surface on the sun because light travels through the air roughly 1,000,000 times faster than sound that you can use standard and estimate the distance of lighting. Lighting is an electrical charge caused an imbalance between strong cloud and the ground or within the cloud. Demonstrate most lighting occur within the cloud. Sheep lighting describes a distant boat that lighted an entire cloud piece. Other visible boats may appear as beat, raven, and rocket lighting. It is because the amount of the electrical energy that flows from the cloud to the ground is so enormous. It is like a very big waterfall or electricity. The louder the sound that you hear, the closer you are to the lighting. Light travel through MS faster than sound. Any way of being struck by lightning can potentially gain or injure someone, resulting in cardiac arrest and damage of the neurological system. But the way someone is struck may also import the kind of the injury the individual might suffer. About 10% of people struck by lightning. Lighting precision system is the type of the lighting detection equipment that determine one atmospheric condition likely to produce lighting strike and sound and alarm. Warning, those nearby that lighting is imminent and giving them the chance or to find safety before the storm arrives in the area. Don't forget the 30-30 rules. After you see lightning, start counting to 30. If you hear thunder before you reach 30, go indoors. Suspend activity for at least 30 minutes after the last alert of thunder. You can tell how far away a lightning stroke is a quantity of the second between seeing the lightning flash and hearing the thunder. 5 seconds approximate 1 mile of distance. If you see a flash and instantly hear the thunder, the lightning stroke was very close. They shatter immediately. Uh, the sighted for lightning strike would increase by about 12% of everyone's seat of one day, resulting in about of a 50% more strike by 2,100. At this point, however, the scientists are unable to predict where and when those strikes will occur. T2 system was a detection radio wave emitted by fast electric current stroke in lighting channel. Stroke can be fast current within the cloud and electron stored in a channel ground. If we light you usually been wide open by something or
Excuse me, Dr. O. I
yes.
think we have less time. We can
Okay.
request our speakers to start their presentation.
Okay.
Okay, thank
Okay.
you.
Okay. Okay. Thank you.
So may I start to request Dr. S.D. Pawar, the first presenter. His title is the Spatial and Temporal Variation of Lightning and Related Losses over India. So I request Dr. Pawar to present his paper. Thank you very much. Dr. Pawar.
Can you hear me?
Yes, I hear.
My screen is visible?
Not yet, not yet.
Please share your screen. It was shared
Please
earlier,
share.
but suddenly gone. Please share.
Okay, it is coming.
Yeah, it is coming. Make slideshow, please.
Maybe you can talk a little bit louder, Dr. Pawar.
Yeah,
Voice
yeah,
is very low.
okay.
Sir, make it full screen.
Yeah, now it is all right. Okay, now it is all right.
Full screen, please, and a little bit louder.
It is not full screen.
Not yet.
And it did not come to my display also. Not yet, I have seen.
Not a full screen. Please make it full screen.
Yeah, actually in my yes.
Mohan, আমার স্ক্রিনে আসেনি।
Yeah, actually, it is not yet full screen. Maybe it is taking time.
Maybe it is taking time. Yeah.
Yeah, now it has come. Okay, I will start actually. I will be talking about the spatial and temporal variation of lightning over India, and if time is there, I will talk little about the losses by lightning over India. In this study, actually, we have used 20 years satellite data. As we know, the TRMM satellite have 1995 to 2014 data, and that we have used to study the climatology and trend of lightning over India. I know it may be little less data, but still it can give a good idea about the variation, means climatology and trend of lightning. As we can see, actually, main environmental condition necessary for thunderstorm formations are instability, or we can say the conditional cape, generally it is called as a cape, then moisture availability and the lifting mechanism. Unless these three conditions are satisfied, thunderstorm cannot form. And some environmental conditions like orography, prevailing meteorological condition, and aerosol help to provide this or achieve this criteria to form the thunderstorm, and therefore they will help the intensification and evolution of thunderstorm. This is the well-known plot from TRMM, and we can see actually this tropical belt is a lightning-prone area, and you can see very clearly actually some part of the India is very active in lightning as compared to, you can see this is the lightning hotspots in South America and
I
North.
think slide is not changing.
Slide is not. Okay, shall I start talking?
Yeah. Now it is okay. Now it is okay.
It is okay. You make it full screen. That will be all right.
Then it is not that slide is not changing. Shall I talk with this only? It is, or it is
No, no.
not. If I make it full screen.
Sir, you increase the percentage otherwise. Percentage of screen. Without pressing view mode, you just increase the percentage of view. Percentage view. So it will be little better than that. I mean, better than not.
Actually, there is a
down right hand side, there will be some percentage. It will be showing 50%. You make
Again, you need to share. Yeah, sir. Yeah.
Okay, this is if I make it full screen.
Yeah, click it.
Right. Click it there.
No, not there. Click it. If it is
Yeah.
not happening, no problem. You can continue with this.
Okay, then I will increase the screen. Yeah, this is
So
on my.
you just close the left hand side other way. Yeah, a little you little compress.
Okay.
Little more.
Okay.
If you can press the fourth one, bottom right. Yeah.
Yeah, this
Yeah.
is a slideshow, but it is not changing the
Okay.
screen.
No issue. You can go ahead like this only. We can see it.
Okay, it is now it is visible.
It's visible.
Okay, then this is actually, as I told, we have used 20 years data to study the climatology, and here we can see the climatology of lightning over Indian in different seasons actually, because as we know, in India, these processes and changes with means atmospheric conditions are very different in pre-monsoon and monsoon, and therefore lightning activity can be also in different regions. It is changing. We can see this pre-monsoon region, pre-monsoon season, this northeastern part and Bangladesh, there is a high lightning activity, as well as this Himalayan foothill of Himalaya also shows very high lightning activity, as well as this southern India, this west coast, there is a high lightning activity. But if you see the monsoon, generally in the monsoon, it is called as the moist neutral condition, or CAPE will be very less actually. And as we know, to start the lightning activity or start the thunderstorm electrification, the vertical velocity or updraft at least 15 meter per second is required actually. And unless there is a CAPE, it is not possible, because release of CAPE only can generate that much that amount of updraft. And therefore, generally, if you see in other country, means other monsoons, South African African monsoon, or this South American monsoon, there is a very less lightning activity is observed. But we can see in the Indian monsoon, there is a huge lightning activity can be seen actually, not only in India, but you can see in this North Pakistan and even Afghanistan, also some region. There is a high lightning activities observed during this monsoon season. And this most of the East Coast also show very high lightning activity. As you can see here, actually, this post-monsoon, there is a very less lightning activity. If you see the first slide and this slide, almost it is a 10 times less actually. There was a scale was 2 and here it is 0.3. Therefore, it is almost one order less lightning activity can be seen in the post-monsoon and winter. And post-monsoon, there will be hardly in this west coast, we can see some lightning activity, and this region also, Pakistan region, we can see some lightning activity. And winter, there is a, because of this westerly disturbances in this Himalayan foothill of Himalaya, we can see some lightning activity. Now I will talk, means we'll see actually what are the causes, or what is causing this lightning activity. Uh, what are the causes for this lightning activity? As I told, the CAPE or the instability is one of the main uh, requirement for the lightning activity to start. And actually, this is, I have plotted this pre-monsoon CAPE. Here, actually, we have used 32 years data of CAPE all over the Indian station, and it is averaged. And we can see actually in pre-monsoon CAPE is not very high over this, even this uh, northeastern part of India, as well as not in this Himalayan region also. But we can see the lightning activity is very high over this region. That means CAPE is not playing very important role in the lightning activity, or at least for the intensification of the lightning activity in over this region, or over Indian region as a whole. Because as I told, CAPE is very necessary to start the lightning activity, but intensification and its evolution is mainly controlled by the availability of the moisture. And you can see actually this here also we have seen actually, this is actually, we have measured by electric field data. Actually, this is a lightning flash rate we have plotted for two thunderstorms, and one is in Kharagpur. It is the eastern part of India, and this is northeastern part of India. And we can see actually the lightning flash rate, even though Cape is very small in this Guwahati, but lightning flash rate has reached very high actually. It is almost 80 flashes per minute. It is a very high flash rate. But if you see the Kharagpur, even though Cape is very high, 2,800 means it is a very high Cape, but still we can see very clearly that the lightning flash rate has reached just less than 25 flashes per minute. Even though it is a very high flash rate, but compared to this northeastern part, region, this flash rate is very small. Just I wanted to show that this cape is necessary to start the thunderstorm, but it is not the intensification or evolution of thunderstorm is mainly controlled.
Adjo.
Hello, yes,
Adjo.
hello, yeah. Intensification or the evolution of lightning is mainly controlled by the availability of moisture and other conditions, not by the cape. Cape is very necessary to initiate the thunderstorm. Then here actually I have plotted the actually sorry, but it is not okay. You can see this is actually specific humidity I have plotted in this side, and here this pre-monsoon or April lightning I have plotted, and you can see actually this where specific humidity or moisture availability is very high. There only lightning activity, it is showing a very high lightning activity. That suggests, as I told, this moisture availability play a very important role in intensification and evolution of the thunderstorm. Cape is necessary definitely, but specific humidity or moisture availability is playing very important role in its intensification of the thunderstorm. Then actually lightning and cape during monsoon. As I told, monsoon is not very prone, or it is not very favorable for the lightning activity because it is a moist. In monsoon, mostly it prevails the moist neutral condition. Means cape will be very small actually. But if you see the Indian region, cape is not very small. Even though this is a trough region, it is more than 1,000 cape you can see actually. And north side of cape, of course, it is a very high cape you can see. And therefore lightning activity is also very high in this monsoon trough region as well as in this north side of the monsoon trough, mainly because of this cape, because moisture availability is no question in monsoon. There is a surface moisture is very high, and this cape also is very high. Therefore, most of the season we can see the lightning activity, and that is the main reason that I feel that in India we are finding so many deaths, because monsoon is the season where most of the farmers will be working on the field, and since we are seeing large lightning activity during that season, the most of the deaths are occurring in that season.
සීනක ඉන්නව නේද?
Yeah, sorry. Then role of orography. As I told, orography also plays some important role in this lightning activity. Here actually we can see because as tall mountains actually night time they radiative cooling will occur, and therefore they will help to for moisture conversion at the foot of hill of Himalaya. This is actually diurnal variation we have plotted over Guwahati, and we can see actually there is a this is local time, and you can see the lightning activity is picking up in the night actually when this radiative cooling is occurring, and therefore moisture convergence is happening in the valley. Then only this lightning activity is picking up. You can see here also actually we have plotted 4 stations. You can see here Siliguri is very close to Himalayan ranges actually, and we can see here this is actually here it is there, but it is in UTC we have plotted actually. It is the universal time, and therefore you can see actually lightning. There is one peak around 17 hours local time, but it is a small peak, and there is another big peak is observed in the late night actually. This is due to orographic effect. As we go away from the little away from the Himalayan ranges, you can see this peak is there, but still there is another peak because this peak is because of orography. And as we go away little away from the again from Himalayan foothill, then you can see this local time 17 hours peak is higher than this nighttime peak, and if you still move away, then this nighttime peak is vanishing actually, because that peak is mainly due because of orography, this moisture convergence is occurring, and therefore it is generating very high lightning activity in the night. Then I will talk little about the trends actually. This is you can see actually pre-monsoon lightning I have plotted here. With this side I have plotted the climatology, and this side the trend actually. This is, you can see the light climatology shows that lightning activity is more over this northeastern part and Bangladesh, but you can see the trend. It is showing the large increase in this Pakistan or this some of the Bangladesh region and some of the Indian region. The lightning activity is increasing. This is a 20 years, and you can see actually if you see the scale are same, and it is almost more than 30% increase in 30 years. You can see in some of the regions, and you can see most part of the India also showing the increasing trend in lightning activity.
Dr. Pawar, can you make it very quick now?
Yeah. Just similarly, if you see this monsoon also, uh, we can see actually there also most of the country. This is even though it is a 20 years data actually, but you can see the most of the Indian region and this Bangladesh or Pakistan, it shows a very high increasing trend during the 20 years. Then I will directly go to the some effect of urbanization also we have studied, and we have seen that most of the cities over India shows the increasing trend in lighting activity because of urbanization. As I told, this in cities act like the island. This is called as the heat island effect. And over island, the convective activities are increasing, and we have seen that most of the big cities, Bangalore, Delhi, Kolkata, most of the cities show increasing trend in lightning activity in the recent years. Then just I will show some of this deaths actually. This is actually I have plotted lightning deaths over India, and you can see actually this is from 1968 to 2019, and it shows, definitely it shows the increasing trend. Of course, this is a blue is population. Population also shows the increasing trend, and that both curves are almost going parallel. That suggests that this increasing lightning trend may be due to uh, increase in population. But if you see some of the states, we have done some detailed study. For example, this Bihar and Maharashtra we have done, and we can see here actually this is the districts of Bihar, and lightning and death we have plotted, and we can see actually over Bihar this lightning density and death count, they are correlating with each other very well. But in Maharashtra, they are not correlating, which suggests that in Maharashtra, lightning density or lightning frequency is not the main cause of the deaths. Even though some districts you can see actually here lightning is very small, but still deaths are very high actually. And we studied I will show just two figures actually. This is CG lightning density, and different parts of Maharashtra we have seen actually. This is we have depth per 10,000 kilometers square we have seen, and you can see in this Marathwada lightning, even though lightning is very small, the depths are very high actually compared to these two region. And if you see here actually this forest cover in this Marathwada is very small actually. Therefore, and if you compare these two regions, there is a forest cover is comparatively high. Therefore, we can see actually these are some of the conclusions what we, the characteristic of thunderstorm also play a very important role in lightning deaths actually. If like thunderstorm like northeastern part, if it comes with very severe weather, mostly people will stay inside and the deaths will be less. But if you see Madhya Pradesh or even Bihar, UP, these thunderstorms are not very severe. Sometimes they will be very lengthy, but they will be, and therefore most of the time people will be working on the field and they are becoming the victim. Therefore, this characteristic of thunderstorm also play important role. Then these low intensity lightnings are very dangerous because they can penetrate through two trees also, because their striking distance can be very small, 10 to 20 meter, and therefore even between two trees this low intensity lightning can penetrate and they can kill the people. then this diurnal variation also play very important role, because as I shown, I am not shown here, but we have seen that most of the states we found that lightning activity starts at very early, means around 1 or 2 o'clock in the afternoon itself, and therefore most of the time people will be working on the field. Therefore, this diurnal variation also play important role, and as well as this low forest cover in some region, because of low forest cover, this lightning deaths also increasing, and as this forest cover is decreasing, that may be one of the reason that this lightning deaths over India may be increasing. Thank you very much.
Thank you, Dr. Power, for presenting a nice paper, including the countries of the South Asia region. Now, I would like to request the second speaker of the session, Dr. Shiromani Jawardhana, Director, Department of Meteorology, Sri Lanka. The title of the presentation is Spatial and Temporal Variation of Lightning in Sri Lanka. So, Dr. Shiromani.
Good morning. I hope it's good morning. So I'm going to present, and most of the content of this presentation is published in a book. So it's a joint publication from myself and Dr. Antti Makela. And so this is the outline. So I'm going to talk about annual, seasonal, monthly, and hour lightning distribution, and lightning early warning also in brief. The Asia, so Sri Lanka also a high lightning prone country. In general, 50 lightning deaths occur according to Dr. Gomez paper. And previous studies, actually, they do this lightning spatial distribution based on thunder days. As we have very limited meteorological stations where we observe thunder days, it's not fully represent the real picture of the lightning activities, especially a spatial distribution of the lightning activity in Sri Lanka, because the complexity of the topographic features and those things, lightning, we have to have a very high resolution lightning data sets. And so this is the methodology. Actually, for this study, we use Vaisala GLD 360 lightning location data from 2015 to 2018. Then we convert the point data into a vector and then a gridded data set. And finally, we overlay over digital elevation model to see the effect of the topography. So this is the annual lightning stroke distribution. This is based on the lightning thunder days, the thunder frequency distribution. And this is the annual average from 2015 to 2018. Like other speakers mentioned, it's very important to identify the hotspots. So we found 3 hotspots here. One, the Central Hills over here, and western foothills of Central Hills, we have high lightning density. And again, over this region, and the southeastern foothills of Central Hills. So this region is where we have a lot of paddy cultivation. So especially farmers working outside area during the daytime. So becoming a lightning fatality victim is very high. The possibility is very high. So I think it's very important to identify this type of hotspots using spatial lightning spatial distribution. So when we overlay this over the digital elevation model, we can see that the coastal region, except this western coastal area, we have less lightning activity in average. And even the highest part of the central mountains also, we have less lightning activity. Most lightning activity concentrated over this western foothills of our Central Hills. And this most probably because convergence of sea breeze coming from this side and this side, when it converge over here, maybe the convective activity is more. And again here, the sea breeze plus the orographic has played a role, the high lightning intensity over this region. Then annual variation, when we map, so we can see it's year to year difference, but still these hot spots, we can see it's all for 4 years. 2015, actually, we found less lightning activity compared to other years. This is the number of flash counts. In general, 3 million strokes per year reported over Sri Lanka. So this is the seasonal variability. So we can see first intermonsoon, that is the transition period between northeast monsoon and southwest monsoon. We have high lightning activity over here, Sri Lanka. And then during southwest monsoon, most lightning activity confined into the lee side of the lee side. And then this is second intermonsoon, fairly widespread lightning activity. And northeast monsoon, again, wind is coming this side. So lee side, we can see lightning activity. And so this is the district-wise lightning occurrence. So we can see the western parts of the country where Kegol district reported the highest lightning activity, especially during first intermonsoon, which reflect in the evening, even in the annual lightning occurrence also. So this is the monthly variation. So we can see month of April is the highest lightning activity we can see, especially except this 2015, all other years we can see high lightning activity, especially over western parts of the country compared to the eastern parts of the country. And again, during monsoon season, we can see lee side of the country, more lightning activity occurs. And this is again the second intermonsoon season, transition period between southwest monsoon and northeast monsoon season. And during northeast monsoon season, again, lee side of the country have more lightning activity. So this is when we compare with the lightning frequency based on the thunder days and GLD 360 data. So we can see especially this higher hotspot over this north central parts is missing in the lightning thunder day data. And this is for the July to December. So this is just I want to show you because we have chosen for years from 2015 to 2018, and there was a very prominent El Nino activity during 2015 and early part of 2016, and again latter part of 2016 and 17 we had a mild La Nina condition. So these might have reflected in the lightning activity during these 4 years. We can see in April, almost 30% of the annual lightning activity occurs in the month of April, so which is the most important month. Least one is occurs during January and December. And when we hourly lightning activity, so we can see evening, afternoon peak, especially between 3:30 p.m. to 5:30 p.m. So this peak, so this reflect this convective activity due to surface heating is most important for Sri Lanka. So when we discuss the possible reasons, so the lightning peak over this north central part is probably due to the convergence of sea breeze and convection due to daytime heating. And then over this sea breeze plus orographic effect, and here also sea breeze plus orographic effect. And during monsoon season, we can see lightning activity during the lee side of the country. So that is possible reason is the convergence of the southwest monsoon and northeast monsoon with the sea breeze circulation. And so other possible is easterly waves and again intertropical convergence zone also. So then the lightning detection, early warning is very important. Like Mr. Abesinger mentioned, actually, unfortunately, on 15th, actually, 3 farmers died in this area, Tanimuruttu area. So this is the, we have right now, we have lightning detection system donated by Chinese government, but still it's in the experimental stage. And based on their data, these are the cloud to ground lightning occurred in 15th April, and this is positive one and this is negative one. And this is the area where we had the 3 farmers killed. They were actually working in separate, different paddy fields, but during this lightning event, they come together and stayed in one place, and so they have become a victim. It's very unfortunate. And these are the intensities. So we can see 30 kiloampere current generated by this lightning activity. So this is our early warning system at present. So we issue this type of lightning advisories based on this data from lightning detection network provided by Chinese government, as well as the Finnish Meteorological Institute provide us near real-time lightning information, not data, but the information, and plus other lightning possibilities from global models. We issue this type of lightning advisories at present. So this is the summary. So highest lightning activity occurred in the when we consider the districts where our administrative districts, Kegol and Gampaha districts. In general, 130 flash per kilometer per year occurs. On average, 3 million lightning counts per year occurred during this 2015 and 18, and highest 50% coming from the first intermonsoon, that is transition period between northeast monsoon and southwest monsoon, and another 25% from second intermonsoon, that is transition period between southwest monsoon and northeast monsoon. So this, especially during intermonsoon season, there's no predominant wind flow, so the variable lightning and convective activity during the surface heating, and this convergence of 3 Bs together with orography effect provide maximum lightning count, 4/3 of lightning activity in Sri Lanka. Thank you very much.
Thank you, Dr. Shrimani, to present your paper in due time. And we got a very good information from your paper. I think this will be helpful in future for taking initiative to reduce the death or casualties and the loss of properties in the country. So now I would like to request my co-chair, Dr. O, to conduct the session for the 2 papers. Dr. O, I request you. Are you here?
See that, Mr.
Yes, he is here, but I can see.
Or should I continue?
Please continue, because it might be maybe just gone for a while.
Okay, okay.
Yeah.
So our next presenter is Dr. Abdul Mannan, Bangladesh Meteorological Department. His title of presentation is Lightning in Bangladesh, Vulnerability, Observation, Prediction, and Preparedness. So I request Dr. Mannan to present his paper. Mannan.
Are you listening, me, sir?
Yes, we are listening.
Okay, thank you. So good afternoon, sir, and welcome everybody to my presentation. I think by this time my previous presenters has already covered many parts of my presentation, even though as my interest is only on Bangladesh territory, that's why I may have to be repeated some of the products as well as some of the pictures also. So actually my presentation contents will be introduction about the lightning activities over the Bangladesh territory in context of gridded data as well as some satellite data. Then I will try to explain you the vulnerability of Bangladesh in terms of lightning.
ভিন্ন নিউটন সংখ্যায় নিউটনযুক্ত নিউক্লিয়াসের পরমাণুকে বলা হয় মৌলের আইসোটোপ। আমরা আইসোটোপ সম্পর্কে আগে থেকে
So conventional and moderation of lightning observation in Bangladesh, then prediction of lightning and its enhancement. Then finally, I will try to highlight some of the research and awareness activities as preparedness in context of Bangladesh territory. So this is the lightning imaging information LIS from the TRM satellite. What I found that in Bangladesh territory, it looks very dark, it's very red. That means flash scale of Bangladesh territory is very high in different years. First one is in 2001 and next one in 2012. And both the cases, what is found that flash rate has been there more than 52 up to 500 and it's above. And let's go for the seasonal scale, because there are the variability of lightning over Bangladesh territory also. That's why first one is December to January, that is in winter season. We found that less number of lightning over Bangladesh territory. And in the case of April, May, the number of flash densities are very, very high than the earlier times. And in the case of summer, that is June to August, what we found that again it is comparatively lower than the earlier season. But if we go for September or October and November, again the flash densities are comparatively lower. If we go for monthly distribution of lightning activities over Bangladesh territory, what we found that in January there is very rare flash densities are available, and in February quite number of flashes are also available. In March it is becoming closer and it has a wide coverage, and in April it is concentrating more and more. If we go for May, it becomes very dark over Bangladesh territory. That means light flash densities are very high, and again in June it is concentrating comparatively lower than in May, and then in July and August, and similarly and go on. And in September, October, and November, and as well as of course in December, specifically November and December, this event are very rare in Bangladesh territory. But in September and October, due to monsoon flow, in association with June and July, the number of flash densities are comparatively much higher, but though their intensities are comparatively low. So this is the total lightning flash densities of the globe. Here we found that in Bangladesh territory, due to concentration of lightning density, it is becoming as a black spotted area in addition to some other hot spot area of the globe. So this is I have taken for further analysis. This one is the case for first one, April climatology. You might have seen that Bangladesh territory, in addition with some parts of East India, we found that the flash densities are very high. And if we move to the 15 April, again situation is almost same. But if we go for 1st May, the concentration over outside of Bangladesh territory is very high, and the intensity comparatively lower in Bangladesh territory. But if we go for 31st May, again situation is almost closer to the earlier one. But if we move to the other times, that is in June, the flash densities are very, very low than the earlier times. But if we compare all of the results together, what we found that from the season onward, that is pre-monsoon onward, the flash densities over Bangladesh territory and adjoining areas are becoming higher and higher, and it continued during the pre-monsoon season. And once the monsoon onset over Bangladesh territory and adjoining areas, its intensities are becoming lower and lower. So according to this analysis, actually NASA has declared 500 top listed hot spots. Out of these hot spots in Bangladesh territory, we have found 3 hot spots are there. One is in Sherpur, that is located over here, and another one is in Bazitpur, that is in Kisharganj district, and next one is at Shahzadpur, that is in Pabna district, and their ranks are 105, 202, 272, and 410. That means the vulnerability in context of lightning is very high in Bangladesh territory. So, but interestingly, some other informations are available. Once the flash densities are not determining factor of hazard or disastrous situation, it has to be considered other factors. We must know that hazard is a function of risk, vulnerability, exposure, as well as also response. I don't want to explain other things. So in consideration of these things, I have taken 2 points over here. One is population density over Bangladesh territory. You might have seen that these population densities are very, very high over the central parts of Bangladesh, Dhaka and adjoining area. But again, lightning fatality rates are different at different places due to lightning densities, flash densities, and other activities. If we mark this one and make a combined analysis, what I mentioned in my earlier slide, we found that the number one, that is top listed death rates, are available over here, and the place which was selected as a top listed hot spots, which was selected as a fourth death rate area, and similarly go on. That means, moreover, if the lightning flash density is over higher in northeastern parts of the area, but due to some other exposure, it has been determined the more fatalities as well as death rate are higher at other places also. But of course, some parts of the northeastern parts of area are also included. So let us have some conventional analysis of what we do have in BMD. We have the 35 stations which have longer recorded lightning reports, but I have taken only the lightning number of days, what they have counted by the local observer and accumulated at the climate division. And what we found that from March to onward, the number of lightning days are being increasing over Bangladesh territory. But in June, July, August, and September, lightning recorded days are comparatively high than October and November, but the fatalities due to some other exposure effect, it is becoming lower within this area. I will show you some other slides where it is very high. Again, in context of annual variation, what we found that in Dhaka, it is in central part, the number of, that means lightning days are becoming reduces, but in the other hand, the place where the place is mostly lightning affected area, that is Sylhet, where the lightning number of days are being increasing. But if we take the 8 divisional headquarters as a representative value of that area, what we found that it was positive. That means number of lightning days are increasing over here, as well as over here. But at other places, it is becoming lower. But in earlier studies, what we found that the number of lightning days were positive over here, and again, it was positive over here. That means in the recent time, due to other atmospheric behavior, number of lightning fatalities, number of lightning day, and other features are being shifted or being changed gradually with the progress of time. Let us see, this is the distribution of lightning days over different months. In every cases, it is not, northeastern parts are included, but in some cases, specifically in May and in April, as well as in the earlier part of the June, when the monsoon are being delayed, during that time, our central parts of Bangladesh are receiving high amounts of lightning fatalities as well as lightning activities over that area. So let us see with the analysis of some daily newspapers report, that is the Daily Ittefaq, Jugantar, the Pratham Alo, and with the period of 2012 to 2016, though the information has been gathered for afterwards of 2016, but I have only trying to showing you the result for this 5 years period. What we found that male populations are more affected and more fatalities are over there as they are working outside, and female number is very less than the of that one. And for other cases, as per the media, we haven't collected any information properly. Of course, this would be divided within this part and this part. And similarly, in the case of injuries, you see the male populations are higher again than the female population. If we go for different categorized people with different sectors people, here we found that a significant amount are dominating by the farming community, and similarly for other cases some significance are also available.
Dr. Mannan, your
Yeah, please,
time
sir.
is very short.
Okay,
Can
sir,
you make it up?
I'll try to come back.
Okay.
And again, you see the highest number of fatalities, what we have found that April and May and June due to the intense lightning activities over there. And if we go for timing, as Dr. Mazhar already mentioned, the morning and noon times casualties are dominating than the other times. If we make the special distribution of the lightning fatalities as well as the affected people, again we found that the Sunamganj and at this adjoining area where most of the people are working in the field during that period, that is in pre-monsoon season, that's why casualties are becoming higher. So in Bangladesh, government has taken or as a disaster as lightning, and accordingly they have formulated the standing order on disaster, and through this formulation different awareness activities are being initiated, as well as some responsibility has been given to Bangladesh Meteorological Department with the Ministry of Information and others also for developing lightning detection strategies as well as the proper and appropriate dissemination of lightning warnings. Similarly, let us see some BMD's efforts are there with the support of government. Actually, we have been working with NASA and ECMOD collaboration, and accordingly, we have been trying to address the lightning activities over Bangladesh territory with this sort of initiative, and these are the objectives. As time is not there, I will not tell you in details about this area, and accordingly, we have analyzed the data from 2001 to 2017. With this 17 years information, we have analyzed jointly with the NASA scientists as well as ECMOD scientists as well as the DSM Nepal scientists, of course from Bangladesh side also. And with this methodology and of course information available from this NASA's different sources, that is also of course TRMM and a space station as well as the GPM systems also. And we have calculated the information. What is found that the precipitation rate as well as amounts of precipitation are highly correlated with the lightning activities over Bangladesh territory. That is the main conclusion of this analysis, and accordingly we have been trying to formulate the result over Nepal as well as in Bangladesh, and trying to find out that the monthly correlation, though individual days correlation is much higher than this one. And this correlation indicates that the area which is having high lightning related rainfall rate are becoming more and more vulnerable for the heavy rainfalls also, and accordingly this information we have been provided in other aspects also. So we are not sitting ideally. Accordingly, we have been augmented some thunderstorm lightning detection system over Bangladesh. Accordingly, we have installed 8 lightning detection system, and accordingly we have been able to monitor the lightning activities over Bangladesh territory. Though the system is still in test basis, of course, at some time after some years or after few years, we will be able to deliver the data and information to the users and stakeholders. That data are being archiving regularly in our server also. And not only that, to emphasize the government's activity, we are also distributing this sort of leaflets in addition to the explaining the lightning and its features and its casualties and vulnerabilities as well as its risk to the local schools and as well as of course in colleges also. And in addition to that, we are also helping with our stakeholders to promote these sort of activities in Bangladesh. And in this process, we are running high impact weather assessment tool, and accordingly
Mannan,
we have.
Dr. Mannan, I think the time is already over.
So we have distributed the thunderstorm and lightning alert system, and we are working with the Again, we are working with the high impact weather assessment tool, and we are going to install this one for addressing the lightning, hail, as well as tornado and squall lines also. And we are going to install the WRF system with the 12 ensemble member, utilizing the information or developed by the NASA through unified environmental modeling system. And accordingly, we have tested this information for Bangladesh territory as well as the Hindu Kush Himalayan territories also, and the result has already been under process of publication, and we are going to install this sort of this system in Bangladesh for addressing the lightning activities over Bangladesh territory. This is the different microphysics which we have been considering. These are the 12 ensemble, and right side is the ensembles of probabilistic forecast for that one, and these are the information flow for that lightning activities. And accordingly, we have tested for the year 2018, and result has been formulated, and accordingly we were able to monitor the heavy rainfall event which was associated with the lightning and thunderstorm over the southeastern corner of Bangladesh. And accordingly, model was able to, during testing, model was able to detect the lightning activities over Bangladesh territory. And my another approach is actually we are not ideally sitting in Bangladesh. In Bangladesh, we have good number of research activities regarding the thunderstorm, but even though now recently our young scientist has already started lightning related research also, and we have analyzed some sort of information, and accordingly we are able to address the lightning related events, that is heavy rainfall events, and we have been developed lightning potential index in addition to the other thermodynamic parameters to address the issues related to the lightning over Bangladesh territory. And my 2 or 3 more suggestions I have in my mind: data and information should be accessible, whatever it is there in BMD or any other places. It might be scientific data or it might be some social data also, whatever it is. And field campaign and ground validation is required and very much essential for this one. And of course, we have to depend on the space-based information and to carry out more and more observation regarding the lightning activities. So thank you, sir, for giving me a chance
Thank
and
you.
to complete
Thank you,
my presentation.
Mannan,
Thank you.
for comprehensive presentation on lightning and its climate loom. Thank you very much. I think we are already late by 15 minutes or so. So our next presentation, we go for the next presentation, and that will be made by Dr. J.R. Kulkarni. So he is a former scientist, IITM, Pune, India. His title of presentation is Lightning Activity over Indian region and its association with different weather parameters. So I request Dr. Kulkarni to present his paper.
Thank you, organization. I hope I am audible and visible also, and my presentation also visible to you. So I thank all the organizers and especially Dr. Tyagi, Dr. Professor Das for giving me this opportunity. Apparently, there was some common between my title of my presentation and Dr. Pawar's presentation. So I have revised my title as Lightning Activity over Indian region and its association with the different weather parameters. Okay. So I have used, so with our research has been published in many papers. These are some of the titles of the paper in JGR, GRL, Indian Journal of International Journal of Climatology, and some more journals. But I am presenting some results from these papers. My co-authors are Kandargaonkar, Teenmaker, Ashanath, M.K. Kulkarni, and Trimbake. So this work is a teamwork done by all this paper, and I am presenting some results from my 3 papers only, from JGR and GRL and IJOC. Okay. Now I will not talk about the lightning data, what I have used. Dr. Pawar has also explained this data. So we have used data from the LIS, that is lightning imaging sensor, for the period, long period. This is for period in the initial paper, but after we continued for the available data, and that is for 0.5 to grid that comes about to 50 kilometers. And over the Indian region, 8 to 30 degrees north and 73 to 80 degrees east. First, we have excluded the oceanic region, then we have considered the oceanic region also. And we have the data for every 90 minutes, and then we made it for 1 hour objectively analyze and make it for 1 hour for studying the diurnal cycle. So this is the picture state where I am coming to my results. So this is the diurnal variation over Indian region, Indian landmass region, and this is the percentage. We converted all the flash data into the percentage form. So if we see taking all India as a one figure, we have the maximum percentage of this lightning activity at 10 UTC, which correspond to 3:30 in the afternoon local time, and percentage of that one also from morning 8 o'clock to 3 o'clock, it is up to 62%. Then after 4 o'clock to night 11 o'clock is 21%, and very small percentage in the midnight to the morning hours, that is up to 14% only. Now, if you see in different season how the percentage varies. So in pre-monsoon season, the maximum frequency occurs at 10 o'clock in UTC, 3:30 in the afternoon, but there are other minor peaks at 8 o'clock in the morning that comes about 1:30 in the afternoon. Also some peaks and minor peak in the night also. And if you see the percentage contribution from 8 to 4 o'clock, that is 64%, and other percentage are not very much. Now coming to the post-monsoon, the things are changed. So multimodal distribution has now become more or less a strong peak in the afternoon hour, and another peak at the 9:30 in the night local, that is 16-hour UTC, and this percentage has increased from morning to the 4 o'clock to 68%. So the diurnal variation has changed from pre-monsoon to the post-monsoon period. Now, if you come to the monsoon, the whole frequency of the lightning activity has reduced significantly, and there is no a single peak. There is a flat distribution from the 8 UTC, that is 1:30 in the afternoon, to about 9:30 in the evening. The reason the decrease in lightning activity in the monsoon season is because of the few reasons. One of them is the cloud-based height. Cloud-based height very much controls the lightning activity. Where the cloud-based height is very low, then most of the rainfall process is because of collision, warm phase, and there is very little mixed phase and ice phase is there. So in the monsoon, most of the clouds over the peninsular India has the stratiform structure. More than 40% is the stratiform structure. Over the North India, convective processes are there. So there is a lot of change from pre-monsoon to monsoon, from monsoon to post-monsoon in the diurnal variability. If we see the annual variation, and this is the flash count that is measured in number of flashes per kilometer square per month, and these are the number of observations. We can see the maximum flash count is month of May, and another peak is September, October. Again, there is a reason here. The strong convective activity is there because of surface heating, and this is also the withdrawal of monsoon and ITCZ, presence of ITCZ, which favors the formation of deep convective cloud. Then we have studied this spatial temporal variability over the Indian region using the NASA data. Now we have considered the variation with respect to the mean surface temperature. So this is a very high correlation between the lightning activity and mean surface temperature. This axis shows the lightning flare density in terms of kilometer square per year, and this is per month, and this is the mean temperature. So there is, we can see the strong association between the mean temperature and the lightning activity. Now, reason is that when the temperatures are very high, they are conducive for formation of the wide thermals over the land region. Now, the wide thermals, what they do? Sorry. So white thermals are there, they can reach very high height in the atmosphere and take the particles for formation, ice precipitation, formation of the cloud system. Now, if we see the flat density and landmass area, so there is non-linear distribution with the landmass area and flat density, and this is the regression equation, number of flashes with respect to landmass area. So there is an increase in the flat density with respect to landmass area. Again, it is related to the temperatures over the landmass compared to the oceans. Now, same way, if we see the distribution of the lightning flat density with respect to latitudes, we can see the number of latitudes as we go north, the landmass is increasing and there is increasing the flat density. This is in the pre-monsoon season. Also in the monsoon season, in the north, there are many convective clouds because of the existence of the this cities, monsoon trough region and deep clouds. And if we see post-monsoon, we have one peak at 18 degrees north and another peak in the northern area. So land-ocean contrast activity in terms of the ocean and seas also we have considered. So in this case, we have found that the lightning activity over Bay of Bengal was 3 times higher than the lightning activity over Arabian Sea and 9.3 times over the land. The reason is Bay of Bengal is the region of forming the low pressure system in the monsoon season and and post-monsoon season cyclonic activity over this region. So these are the favorable grounds for formation of deep convective clouds and which are also favorable ground for forming the lightning activity over the region. Now, if you come to the Arabian Sea region, there is the bimodal distribution peaks in April and November. This is not very high compared to the Bay of Bengal, but the peak in the April, November. Over the land, the peak is in May and September. Again, May is the pre-monsoon month and September is the monsoon. When the monsoon is the withdrawal phase and IT season comes over, this is coming down and deep convection our convective clouds are developed, forming the favorable situation for the lightning activity. So if you see the Bay of Bengal, then the unimodal distribution is observed over the Bay of Bengal with peak in the month of May. The maximum activity over Bay of Bengal occurs more at northern latitudes compared to the Arabian Sea. Arabian Sea, the activity mostly is at 12 to 14. Maximum activity comes at is seen at 12 to 14 degrees north latitude, but over the Bay of Bengal, it is 28 to 38 northern. Now that is the reason where the monsoon system and the monsoon season, the lot of low pressure systems are formed like depression, deep depression, and also the during the pre-monsoon month and post-monsoon cyclones, they move northward. So that is the reason we are having the large activity of Bay of Bengal region. Then the land-ocean contrast is dominated by monsoon. So as I told, in the monsoon season, the cloud bases are very low, not very high, particularly over the central and peninsular India. So when the cloud bases are very low, then the most of the rainfall preceded by collision and the ice phase and mixed phase region are very shallow and they are not very conducive for formation of lightning activity. Now, if you consider the El Nino and La Nina conditions, we have studied the lightning activity during El Nino. So our study showed that the lightning activity is 18% over the land and during the El Nino year. The reason is, again, we are attributed to the increase in surface temperature during the El Nino period. El Nino period, what has happening is instead of the convection, the area is dominated by subsidence and clear skies are there, and the convection has been shifted to the eastward side. So this is the reason when the surface temperature is very high, and that conducive for formation the strong thermals, which take the atmospheric water vapor and cloud water to high level, and they form what is known as superlative types of thunderstorm, And most of the days during this period are because of the positive lightning. Positive lightning occurs when the cloud bases are very high, and that has been formed in the El Nino condition. I'm not showing the results when the dates are more in, why the dates are more in El Nino condition come La Nina condition. So the difference is there in the El Nino and La Nina condition, and that can be attributed to large scale convection, then the sea breeze convection, and the continental and oceanic convection. So with this, I conclude my presentation. In summary, I tell that the diurnal variation, we have studied a diurnal variation, then a monthly variation, annual variation, then interannual variation, latitudinal variation, land-sea contrast, and variation with respect to El Nino and La Nina. All the details are available in my papers. These are some of the 3 papers, but more papers are there in which we have studied this phenomenon. So with it, I end my presentation. I have consume whatever time given to me. So I thank everybody. Whatever, if extra any questions are there, I am very happy to answer those concerns. So thank you very much and namaste. Take care.
Namaste. Thank you very much, Dr. Kulkarni, for a nice presentation, and especially the sorry, land and ocean contrast. What you have presented is nicely, I think, mentioned, and we have seen that Bay of Bengal has 3 times activities, lightning activities than the Arabian Sea, and also the peak in the land and in the ocean. So I think all these papers presented in this session will be helpful in making some decisions on the reduction of casualties over this region. I must thank you, all the presenters, for nice presentation, and also I thank my co-chair. Now it is over, Dr. Dash, Someshwar Dash.
Yeah, thank you very much, Dr. Karmakar, for conducting the session very smoothly. I also thank the co-chair, Mr. Kyaw Lewin Ho of DMH Myanmar. I hope he's still there. So thank you so much. I see that we are running the session by about 25 minutes late. And so there is no time for live question answer session. I can see that some of the questions are being asked on the chat box, and there is a live interaction between the audience and the speakers on the chat box. So please continue that. At the end, if there is a time, then we can take up some live questions also. Unfortunately, our Zoom time limit is, I think, up to 2:30 p.m. So we must wind up before that somehow. Otherwise, the Zoom will be disconnected after that. So without losing any more time, now we start the next session on lightning prediction. The co-chairs of this session are Professor Deepak Rayal of CDHM, Tribhuvan University, Kathmandu, Nepal, and Mr. Karma Dupcha, Director of NCHM, Bhutan. I hope both the co-chairs are present. Professor Deepak Rayal, are you there?
Yeah, namaste. Good afternoon. I'm here. And I think Karma is here.
Probably he is not, maybe he's too
Okay,
busy.
if he's not here, I will take care about this session.
Thank you so much.
And I just want to let you know, all the presenters are here or not? Soma, Dr.
Yes,
Soma?
yes, I am there. I am there.
Yeah, it's a long time
Good
to see
afternoon.
you again.
Yes, sir, yes.
Yes, I'm here.
Malis
From
and
Sri Lanka, Mali. Yeah.
Yeah, okay, they all are here. Is there any announcement, Dr. Das?
Yeah, please ask the speakers to stick to the time. Maybe we have to reduce a few minutes.
I will give them 12 minutes and 3 minutes for questions. I think they can understand. And without making any delay, I would like to start with Dr. Soma Sendre from IMD. Please, Soma.
Yes.
Proceed your presentations. And we are, I'm at 1 o'clock in Nepal. So I'd like to.
You're hungry.
Yeah,
So,
it's lunchtime.
Yeah,
Take
yeah,
care
I can
about that.
understand. I'm sorry, it's not going into the viewer mode. Yeah, can you see it in the presentation mode?
Yes, we can see it.
Yes.
Okay. Good afternoon, everybody. I have been. I'm one of the people standing between you and lunch. So I'll try to wind up some parts quickly. And any questions you have, we can discuss in more detail after the presentation. So this is about thunderstorm and lightning predictions in India. If we see the annual climatology, this left-hand figure, if you see, uh, we have predominantly high values of thunderstorm activity over northwest, especially over the Jammu and Kashmir region, and again over Bengal and adjoining Bangladesh, of course, and over South Peninsula, extreme South Peninsula. So these are well-established results. Different studies have indicated the same. And if we go by month, we have the thunderstorm activity picks up as the land heats up. And the peak, if you see, this is comparatively, sorry. Yeah. So if you see 2016 to 2019, mostly from April to September is the prime period when thunderstorms are over the Indian region. This is again from two other papers. Dr. Tyagi sir is here. I think I've seen Mr. Yadava also in this webinar. So from their papers, it has been taken. If you note, the regions of high thunderstorm activity is also correlated well with the high lightning activity. So very well correlated. It is expected, and we need to be cautious about it. If you see the trend of thunderstorm days, if you note that in the 50-year pattern, for example, if you take 50 years data, there is a decreasing trend over east, central and east, northeast India. But if you actually take the data, you note something very peculiar. Uh, yes, the data is decreasing, but it has decreased up to 1993 or 94 for East Central India and about up to about 2003 for Northeast India. Beyond that, thunderstorms have started to increase. Frequency of thunderstorm days are increasing. There is no significant trend anywhere else. In just keep this picture in mind when you go to the next one. So the region where thunderstorms are most predominantly happening, that east and north, east central India and east India, we are seeing an increasing trend. So if you really see the increase in the thunderstorm deaths, which has been shown by other presenters also, this is from the National Crime Research Bureau report. Currently, we are at 2,500 and above rate of death. And since the thunderstorm frequency is increasing, the death frequency also seems to be increasing. And again, if you see the region where it is happening most is over central India, which is one of the prime regions which is also a peak thunderstorm occurrence region and also of death. So this is something that needs to be taken very seriously. Post 2017, a lot of new initiatives have come up in IMD. I'm from India Meteorological Department, in case you missed the first slide. So various radars have come up, different Doppler weather radars, and they're now functioning as a network. Data from a surface lightning array network has come up. I can see Dr. Pawar is there in this webinar, and Dr. Pawar is the main person for coordinating this IITM effort. Inside 3D satellites are there. We have the Himawari satellite products are coming, and of course the models have improved. Really, that has been a significant improvement brought about a significant improvement in our thunderstorm forecasting. I'll show you the results. So some of the observation products, if you see, we have the lightning network and the radar network. I have drawn them, put them side by side. If you see, there are radar holes over, say, Rajasthan and Gujarat, and again over Chhattisgarh region. These are not necessarily the regions of low thunderstorm frequency, but in fact, Chhattisgarh is one of the primary thunderstorm, primary lightning affected regions of the country. So there, what do you do for warning the people? So this lightning data has been a real help for addressing the issue of thunderstorm nowcasting and short range forecasting. The other thing that I want to highlight is the data from the aviation network. The people who are familiar with IMD's functioning, we have an entire aviation sector. Earlier, it was a bit difficult to get this data on a common platform. So that has happened now, and it is in common language and it is available in real time for analysis. So this is an additional benefit rather than just the synoptic observations from observatories. The observations from airports have now been integrated into the operational forecasting chain. So that is why I have included this particular portion of this slide. A lot of mesoscale models have now come up in 2017, and if you remember, sorry, in 2018, there were severe thunderstorms over the North Indian region, and more than 200 people died in each of 2 or 3 instances each. So the government took it very seriously, and especially the Ministry of Earth Sciences, through its organizations, the Indian Institute of Tropical Meteorology, National Center for Medium Range Weather Forecasting, IMD, they have developed a lot of mesoscale models. So the point is this, that on a day-to-day basis, they provide a very good indication of thunderstorm activity, and they're operationally being used. And I can honestly say they have given a huge boost to our accuracy of thunderstorm forecasts. The last one that you see here, I'll talk a little more in detail later, but I'm running short of time and I've been given 12 minutes. When you talk of the actions that we take, the first action we do is pre-season preparedness. In this pre-season preparedness, I must highlight the effort taken by the National Disaster Management Authority. See, thunderstorm forecasting is not, or is not the only thing that we can focus upon. The reaching up to the last mile, the actions to be taken. A lot of government departments, lot of state government, national level departments are involved. So their coordination is a big task. So the National Disaster Management Authority is pretty much the umbrella organization for organizing these things. So they are there from the village panchayat level up to the national level for coordinating the various efforts. And that is not just operational weather forecasting, but also the prior to the weather forecasting, there's a slide later, I'll show you that, where they come into the picture. Then we have pre-season exercises, and we have the state level interaction meetings. Prior to every season, we have what will be the likely weather of over the particular state, part of the state. So this is one of our pre-season exercises in Ranchi. So with media people, we have to enlighten them. Otherwise, if we don't share information, oftentimes panic is created because of poor knowledge. Disaster managers are brought into the picture, and state government officials, district collectorates, panchayats. So a lot of efforts go on, and here NDMA is a very prime supporter in these activities. The NDMA also has a lot of resources for increasing awareness. I'm just highlighting the resources for lightning, but there are other resources too. Coming to the IMD medium range weather forecast, we have IMD forecast structure, so to say. We have a medium range up to 5 days, short range up to 24 hours, 48 hours in the prime thunderstorm season, and then nowcast. So this is all three scale forecasts are shared with various authorities to warn people, warn the state authorities, the public, at as much accuracy as possible, as much in advance as possible to take action. So if you come to the medium range weather forecast, I will not go into the details of how we do it, but please understand it is an all India effort with all state meteorological centers who are part of a daily video conferencing system. And then the warnings are issued. at a state level for districts and in the national level for subdivisions. So both, then they flow seamlessly into the nowcast scale. If you see the thunderstorm distribution, just shifting slightly, we, for India, like I just told you, we have thunderstorms primarily happening, and here it shows the intense thunderstorm periods. So March to June, we have a special project, which is the FDP storm project, where we pretty much address the main the thunderstorms are the focus for all meteorological centers, the entire forecast mechanism. Similarly, from June to September, we focus on rainfall. So during this March to June, rather it was for a long time, Dr. Someshwar Das sir is here. Many of our seniors who are already, who have retired, Dr. Tyagi sir, Dr. Rathore sir, they're aware of this start of this project from 2005. And from 2017, it has become an only Indian project, and the similar, a lot more development has happened. And because of that, we are now able to give, for this particular period, we calculate verification scores. We are funded by taxpayer money, and we have we are answerable to the public, and these statistics are published every month or at the end of the season. So if you see something, this is probability of detection versus false alarm ratio. Our false alarm ratio per year, if you see 2016 to 20, it is decreasing. Our probability of detection is increasing. If you take the blues and greens to mean good forecast, if you see our probability of detection is improving. Whereas our false alarms, if you see West India is not so good, but North India is getting better and better. So, but if you see in the month-wise score, this is how do we perform? Because this is again something we have to give to disaster managers. How good are our forecasts? If you just take quickly the accuracy scores, we tend to over forecast thunderstorms in March. This is, we are seeing every year. It is improving, but we tend to over forecast in March, and we are under forecasting in June. A large part of it is because in March, when you see the initiation of thunderstorms, it is not necessarily going to reach a cumulonimbus stage to give a full-blown thunderstorm. It may often die down from the cumulus stage itself, whereas in June the opposite happens. Oftentimes you presume it will not grow, but it grows into a very severe thunderstorm. So if you say the nowcast scale, which is conducted at the state level, here two SOPs are in place.
Can you please conclude?
Okay, so, okay. So do I have 2 more minutes?
Okay.
Okay, thank you. So 3-hourly nowcasting, this is done throughout the year, throughout the day, 24/7, it is carried on. So this is something for 21 categories of thunderstorms, different phenomena, severe weather, all over India, all districts and stations, thunderstorm, the nowcasts are issued. Here too, if you see, the accuracy is improving, and here again the false alarms are decreasing. And this is all because of the earlier I'd shown you the improvement in observations and forecasting resources. When we come to very specific, short location-specific nowcasts, we have something known as the Damini app. I was hoping Dr. Pawar will speak about it, so I will not have to, because he's in charge of this app from Indian Institute of Tropical Meteorology, and there is another app, Rain Alarm app. So these are two apps which are giving very location-specific, up to 40 kilometers for 15-minute ahead. It is giving location-specific nowcasts. In addition to all those forecasts, we have what are known as nowcast bulletins. These go off when there is severe weather. So these are you can see in local language, and for various states in their respective local language, along with the warnings, we are now sharing impact warnings. So this is in the medium range. I saw something in that scale from Dr. Mazharul Aziz in Bangladesh, and from Dr. Shiromani Jayavardhan from Sri Lanka. but we are also doing the same in the nowcast scale. So this is something that is that has to go. This is, I would like really focus on this slide. Our observations are coming in, model forecast products are coming in, visualization tools are there, and this is the operational forecasts that happen. After that, the dissemination starts, where we take the help of NGOs such as CropSea, central and state government dissemination mechanism, and also we have the pre-season exercise. Where do we fail? Because deaths still happen. 2,500 deaths do not happen. And if you see, our forecasts are improving. We are basically failing in this category. Our linkages are still not robust and rugged enough to address the forecasting, and we're improving every year. But still, that is, I'm frankly saying, that is something we have focused, and we are focusing a lot on this aspect. So a lot of new initiatives have happened. I will not have the time to discuss these. Common Alert Protocol has come up, and it is going to be implemented even more very shortly. We are going to different sectors: power, health, transport, urban sector, GIS-based warnings. When you go through a part of the highway, you should get nowcasts. You should get every forecast up to 5 days seamlessly from 15 minutes to 5 days. The forecast will be available. So we are working towards that. And this is a crowdsourcing portal. Believe me, this has been a very, very big tool for us to use for severe weather reporting. That also we are doing. And thunderstorm test bed, this is a subject in itself. We are building up a thunderstorm test bed in Bengal, Odisha region. Hopefully we can share some results within the next 2 years. Thank you. A lot of work, but I'm sorry, I hope you've understood.
You have a lot of work. Excellent presentation. Thank you so much. I think there will be a question and answer session at the end of everything. So I would like to invite next speaker, Malis Fernando from Sri Lanka. Malis is here?
Yeah, I am here.
Yes,
Wait,
please, Malis.
I'll just share my presentation. You can see my presentation, right?
Yeah, it's okay.
Okay, let me go through it. So, first of all, good afternoon, everyone. I'll rush through this presentation since we are running out of time.
Full screen, please.
Okay.
Full screen.
It's in full screen, right?
It should be full, yeah. You have to go to the slideshow mode. Yeah, okay.
Yeah, no, it's okay.
This is good.
It is, right?
Yeah.
Okay. So, good afternoon. I'm going to present this research work. It's the utilization of indices for lighting forecasting in Sri Lanka. Although this research
Now disappear.
Wait. I'm having trouble with my network.
Okay.
Hello, you can hear me, right?
Yeah, we
Okay.
are hearing you.
Malik Fernando, author of this work. Mr. Malin and Mr. Premalal also are the other authors. So let me go through the flow of this presentation. I'll be basically talking about 3 major sections. At first, what is the study and how did we do it? Finally, what we could achieve.
Can you share your slides?
What do you mean? Sending there?
I'm not seeing.
Malid, your presentation is shared, but it is gone. Please share again.
Okay, wait. Okay, right?
Not, still not.
Still in the way.
It says now sharing screen.
Okay. Please
Okay.
do in presentation. Okay, this is okay. Yeah.
Okay, now let me describe this. As I mentioned, this is a kind of a forecasting of trying to forecasting lightning by using some of the indices that being accepted by the most of the world. Is no natural phenomenon that has both good and bad consequences. Even now, thunderstorms diversely affect from many sectors, including marine, agriculture, etc. With advanced technology, somehow we can pass thunderstorms. But if you remember the last presentation, very challenging about forecasting these thunderstorms. So conventional forecasting is a time-consuming work in forecasting thunderstorms. Thus, the lead time is inadequate. Instead, indices along with numerical weather predictions could do a better job here with a higher lead time forecasting of thunderstorms. Instability indices have been widely used in the field of meteorology, particularly in forecasting, because numerical values forecast better decisions. K-index, total index, and liquid index are some of the widely used in the instability indices. Considering the statistics with regard to lightning strikes, we can observe that around 50 deaths are annually reported in Sri Lanka. March, April, and October, November are the peak months of thunderstorms, also called intermonsoon. These intermonsoons contribute around 50% of annual rainfall of the country. Therefore, these two periods are very important for the most of the people's livelihood. Let us have an idea. How did we do this work? Here is the data source we use. Those are especially this global lightning data, also called GD360, from Finnish Meteorological Institute under the severe storm warning. So we use this data as for the strokes or thunder observation. In addition to that, NSF lateral analysis data, ECMWS ERA 5 data used. Study period was October, November months for 3 years, from 2015 to 17. The strokes that have been observed in these 3 years. Meteorology, all the observations were plotted against the observed time of the strokes. So data tracked with regard to the thunder observed time and location. Cost search for the particular events and activities using some of the parameters like wind and divergence. Here is the most important section. The research A is an occurrence time. As you see, it's a bell-shaped one with 9 to 2 UTC time peaks of strokes observed in Sri Lanka. That is the peak time of thunder. B represent.
Okay, there is a communication problem with Malit. Malit, are you here?
Wait.
We lost your all slides. So can you reconnect? Can you share
I'm
your
sharing it
slides?
again. Sharing again.
Yeah. And your voice is not that much clear.
Yeah, I think it's because of the network. I'm sorry about that.
I can understand this, but
okay, you can see it right now. Okay.
You have a very limited time remaining.
Yeah. Okay, you can see it right now, right?
Not sharing. Please do it again. And try to finish within 7 minutes from now.
Yeah. see it right now, right? You can see the images, right?
Yeah, now it's okay.
Okay, the figure B I was telling, that is on the percentile. We could observe kind of higher places here in the western side and here in the southeast side. The third one, or the map C, is the average 10-meter winds over Sri Lanka during the second winter monsoon, which is on the this period. So the winds we could clearly see kind of convergence in the western side as well as a trough area in the southeast.
I think as far as possible, Malis, can you please conclude your presentation without the slides, because it's very, I think there is a big problem in internet in your location. That's why without sharing the slides, can you conclude whatever you like to say and what is your findings within
Okay.
5 minutes? 5 minutes.
Okay, I will. So maybe I'll share my slides with you later. So it is basically accepted that Cape is a good indicator of thunderstorms. But here in these charts, in our research, we could observe that Cape and CIN both are not follow aforementioned widely accepted concept, which means many of these strokes have been observed during the minimum value of Cape and CIN. So we have plotted these graphs. You may see them in later. And I'll go through the other one that we could see lifted index and K index are going with the widely accepted norm, which is which lies, if we go to the lifted index around -2 to -6, K index around 39, 40, something like that. Of course, these are on the images that I cannot show at the moment. So then I'll brief what are the points that that we want to mention in this research. So the first one, as I show, the strokes lies around 9 to 13 UTC in Sri Lanka. That is the highest peaks of thunder observation or lightning observation during this day.
Walid, are you here again? Walid?
Seems
No,
his
okay,
internet is
okay.
fluctuating a lot today. So
We should proceed for the next. Javed, are you ready? Are you ready?
I can hear you clearly.
Okay, okay, Maris, try to conclude.
Okay, that is what I'm doing. I'm sorry. So, okay, I'll go with 3 points at the end. So that would be much convenient. Okay, this research revealed that Cape values do not play a vital role in development of thunderstorms in country. It could see that it is capable of developing thunder even when Cape values are minimum or less than 500 joules per kilogram. This could be mostly due to significant energy that tropical country receive throughout the year, but without occurring convective activities or thunderstorm. Simply, we may say that indices like K index, lifted index, and total index highly impact on convection than K in tropics. The high chance occurs thunderstorms in Sri Lanka found to be around 9 to 13 UTC. And I think that's all.
Okay, thank you, Maris. Thank you. We will go for the next presentation from Javed Maindad. He's from University of Dhaka, Bangladesh. Please, Javed, I think you should start by yourself about your titles and about your findings. Please
Thank you,
proceed,
sir.
Javed.
Welcome, everyone. Firstly, I would like to thank organizing committee of this webinar and Honorable Chair and Co-Chair for giving me the opportunity. I am Javed Maindad, working as a research assistant at the Department of Meteorology, University of Dhaka. Today, I will discuss about the NWP and machine learning model for lightning forecast over Bangladesh. So let me share my presentation first.
ये प्रोग्राम सुनते हैं, बढ़िया हो रहा है। अभी पाकिस्तान वाला दे रहा है प्रेजेंटेशन। हाँ,
I think everyone should be muted.
Please mute everyone except the speaker and the co-chairs.
So can you share my? Can you see my presentation?
This is fine, Javed. You
Okay.
go for the presentation mode.
Thank you. So we all know that lightning is a natural electrical discharge that happens within a very short time and with a high voltage of electricity. And if we look backward from 1990 to 2017 over Bangladesh, we can see
Javed, I think you go for the presentation mode.
Okay.
Slideshow mode.
Yeah. Is it okay now?
Yeah, this is fine.
Yeah, thanks. So if we see from 1990 to 2017 over Bangladesh, then we can find that the lightning fatality rate is increasing gradually. So it is very crucial to provide a accurate lightning prediction over Bangladesh to prepare the local people and reduce the impact of the lightning. So, but nowadays it is very easy to actually produce the lightning forecast using the satellite observation from TRMM and International Space Station, and also with the help of NWP like WRF model and also the machine learning. So if we discuss about little bit the mechanism of lightning, then we can see lightning needs grapple ice and other solid hydrometeors particle collisions to generate or separate the charges. And for this reason, abrupt plays very crucial role to make collision among the hydrometeors. And also the frozen condensers are very important in this regard. So our objective of this study is to determine the influential meteorological parameters for lightning, and finally we try to build different lightning forecast techniques using NWP and machine learning models over Bangladesh. So this is the technique one which have been developed when I was in my internship at the Department of Atmospheric Science, Central University of Rajasthan, with the supervision of Professor Dr. Someshwar Das and Professor Dr. Tohida Rashid. So in this method, actually we take 9 cases based on the SQL data that has been collected from BMD and the lightning imaging data on board International Space Station. And actually we compare the model efficiency. We calculate the model efficiency by comparing the model derived reflectivity with the observed Doppler weather radar reflectivity, and finally we build a model which is called fitting probability distribution to forecast the lightning. So here is the brief description of the cases. Here actually we have the date of the cases and the occurrence time with the peak flashes and with the specific location of the lightning. So when we compare the model derived reflectivity with the Doppler weather radar derived reflectivity, we can see we actually detect the same grid box in both reflectivity, and then we make a Pearson correlation, and we can see there is a high correlation between them. But the thing is that there is a little bit spatial deviation. And for the 28th February 2019, we say we actually did the same thing, and the correlation is quite high. And when we actually try to figure out which variable are important to forecast the lightning, then we found that lightning flash are very much sensitive to the vertically integrated cloud microphysical parameters such as cloud, grapple, ice, and snow. And from the scatter plot, we can make it sure. So using this hydrometeors and the lightning flash, we actually combine all the 9 cases and try to forecast. But in the figure, we can see that there is no linear relationship among them. Lightning flash rate here actually follow the relay distribution, and vertically integrated hydrometeor flow follows exponential distribution, and it cannot be actually represent within the linear relationship. So we actually feed those distribution and produce this equation, and by deriving this equation we can predict the lightning flash numbers probability using this table. So it was our first technique, and the positive thing of this technique was the model efficiency is very high, and actually the relationship between flashes and the vertically integrated cloud microphysical parameters are good actually, and the fitting probability distribution actually describes the relationship between lightning flash and the vertically integrated cloud microphysical parameters well. But the limitation of this technique was this technique do not provide time and specific forecast. So to fix this problem, we go for the technique 2, and this is a machine learning based technique. In this part, actually, we take the same model output, which is derived from the WRF model, and we investigate the relationship between lightning flashes and pressure and temperature at the lifted condensation level and Cape and Sholter indices. And among the machine learning model, we took random forest support vector with 2 different kernel, which is radial basis function and polynomial kernel. Actually, we choose the machine learning model based on the data characteristics. So actually, machine learning is a very handy tool. In this technique, we do not have to determine the relationship among the variables. Machine itself learn the relationship among the data, and then it actually apply it over the data. So here you can see the correlation among the variables like flashes and the pressure and temperature at the lifted condensation level, Sholter index and Cape index in the heat map. And it is clear that flashes are very much correlated with the Cape with a positive strong correlation, and temperature at the lifted condensation show negative moderate correlation with the lightning flashes, and Sholter index shows negative but weak correlation with the lightning flashes. So using those data in the machine, we actually produce the output, and this is the final presentation of the machine learning output. Here the blue line indicates the actual data, and the other line indicates the model output from the machine. And from the bias, from the error, we can see that random forest provides the best actually forecast for the lightning flashes. So this is our second technique, but in this technique, we can provide the time and location and specific lightning, but the thing is that machine learning is a data-driven process. So to apply this actually model, we need to run this model for long and quality data set. So for this reason, we are planning to use at least 1 or 2 seasons for this model, not only just 9 or 10 cases. So this is for the technique 2. And the most important thing is technique 3, which is deterministic forecast. The goal of this technique is to provide time and location specific forecast, which is very much crucial in terms of lightning forecasting. In this part, WRF model derived normalized maximum reflectivity and integrated hydrometeors and upper level vertical wind actually above the 300 millibar level has been determined lightning potential area and time. We do normalization as the above variable as we have different type of variable and they have different ranges and unit. So we make the normalization to make it in a one or within a defined range, which is 0 to 1. And to normalize different variables are actually get from the max min scaling. Then we consider the reflectivity at the vertical, at the each vertical level above 35 dBz, because we actually assuming that where the reflectivity is more than 35 dBz, the lightning is more potential to occur there. And beside, we use upper level vertical wind and solid hydrometeors, because actually, as I already mentioned, that solid hydrometeors collide each other and generate the charges, and upper level vertical wind actually triggers the collision. So that's why vertical integrated hydrometeors and updraft actually vertical wind are very important in this regard. So finally, we build actually this equation, which is called lightning potential equation. And here we actually what we did, we deduct the lightning reflectivity threshold value from the reflectivity, and we sum up with the multiplication of vertically integrated wind above from the 300 millibar level and vertically integrated hydrometeors. So when we compare the our model product with the real observation of International Space Station's lightning imaging sensors data, then we can see there are little bit distributions difference among the observation and the lightning and the model product. But the important thing is in both case almost same area detected for the lightning potential, and we do the comparison for the another day, which is 25th February 2019, and here we can see that sorry, here you can see the model actually overestimate rather than the real observation. But there is one issue, as the ISS is a polar orbiting satellite, so it cannot cover all the lightning activity over the Bangladesh region. So maybe that was the reason behind this, that the model estimated more than the real observation. So to fix this issue, we try to compare our model product with another product, which is Baron model. Actually, Baron provided a lightning flash rate, total lightning flash rate, and we try to compare our model product with the Baron model product. And here is the actually the comparison. We do this for 17 April 2019 and at the 3 UTC, and we observed that at that day, within this time frame, there was a lightning activity over Bangladesh and adjoining area. So in this figure, in this two figure, we can clearly see that the both two model are providing the same type of lightning distribution, although actually Baron providing the total lightning flash rate and we actually providing the lightning potential area. So this is for our model verification. And the pros and cons of this technique
Javid, try to sum up.
Yeah, I will sum up within 1 minute. The best part of this technique is that it can provide the time and location specific lightning forecast, but we have to trade off. You know that when we are trying to provide time and location specific forecast, then the accuracy can be considered. So we have to keep in mind. So further, we actually planning to test the skill of the model using different real-time observations. So there is a little description of the Baron model, what actually Baron do. Actually, recently, Department of Meteorology, University of Dhaka, and Baron generating lightning forecast for the research purpose over Bangladesh, and they do actually similar kind of methodology for detecting the lightning. They take the reflectivity where the reflectivity is greater than 20 dBz and the temperature is below freezing level. Then they actually apply these two equations for the land-based convection and the maritime convection. And after sum up all the lightning flash rate, they are providing the final product. So here is the final product of the Baron model, that is showing that the reflectivity and total lightning flash rate shows similar spatial distribution at 20 over Bangladesh during 22 April at 10 UTC. So which will be happened at the 4 BST over Bangladesh. So let's see, we can actually validate the accuracy of the Baron model in our eyes at 4 BST in our time. So that is from my side. We can see that vertical integrated hydrometeors, reflectivity and stability indices, upper level vertical wind shows a strong correlation with the lightning activity. To illuminate the relationship among these variables, we can use both NWP and other probabilistic approach as well as the machine learning. In some technique, we can get some only lightning flashes, but with the high accuracy, but in some cases we get the time and location specific lightning, but with the lower accuracy. So to fix which model actually provide the best forecast, we need to actually test the skill of the model with the real observation. So thank you again.
Thank you,
this is all from my side.
Thank you, Javed. You are almost in time. So thank you very much for the organizers for giving me this opportunity to chair the sessions. And thank you all three presenters. Due to some technical problem, we were not that much clear about the presentation by Majid, and we hope we will get his slides so that we can understand a little more. And Sama and Javed did excellent. And I have no more comments at the moment, so we can go forwards. And now I think I will, Professor Das.
Okay,
It's up to you
thank
now.
you very much, Professor. Yeah, thank you very much, Professor Deepak Arial, for conducting the session so smoothly. Unfortunately, we could not get the other co-chair, Mr. Karma Dukchu from Bhutan, but session was conducted smoothly and on time. Of course, we are late. I think we are running late by about almost 35 minutes or so. And we have to complete this entire session before 2:30, otherwise our Zoom session will stop. So without delay, I know that all of you are hungry, and unfortunately in this kind of webinars, we are not able to provide the lunch break. I would have preferred to have at least 5 minutes screen break, but because of the paucity of time, I think we have to continue. So without delay, we will start the next session, that is the country presentations and remarks. And the co-chairs of this session are Mr. Sunil Karyavasam from Sri Lanka and Mr. Ahmad Rasid from Maldives. So are you to present, Mr. Karyavasam and Mr. Rasid?
Yes, both are there.
Great, very good. Thank you so much. So now I hand over the session to you. And I also, I think, suggest that because the time is so tight, so instead of 7 minutes each for the country presentation, we can try to have within 5 minutes each, if possible. So with this, I hand over the session to the co-chairs, Mr. Karyavasam and Mr. Rasid. Okay.
Thank you, Professor Das. Welcome to the session 4 of this very important webinar. And this session will be co-chaired by Mr. Sunil Karyavasam from Sri Lanka and myself, Ahmad Rashid from Maldives. During this session, we will have a presentation from 6 SAMA member countries and remarks from 1 regional partner agencies of SAMA. As Professor Das highlighted, we are running behind the time, so we will allocate each presentations 5-minute durations. If agreed by my co-chair, Sunil Karyavasam, I will proceed with the first 3 presentations and hand over to my colleague, co-chair, to carry forward with the remaining 4 presentations. Is it okay to proceed?
Yeah, it's okay. I think so. You can go ahead with the first, say, 5 country presentations, and then the remarks I can take over. Okay.
Okay, thank you. Without wasting time, first on the agenda is the presentation from Afghanistan. May I invite Mr. Nasim Muradi from Afghanistan Meteorological Department to continue with the country presentation. The platform is yours, Mr. Nasim Muradi.
Okay, thank you so much. Please share my presentation.
Oh, you want me to share the presentation? Is that?
You have it?
Okay, I'll try to share it with you. You can switch on your video at least. Can you?
Sorry?
Can you switch on your video, please? Sorry.
Yeah, I will share. If you don't have my presentation, I will share my screen, okay?
Yeah, please share your screen. Can you share your screen?
I am seeing the message that Dr. Das is sharing the screen. So if both
Somesh, I think
together,
you have shared the screen.
Yes.
Somesh sir, you please stop unsharing.
That is visible now?
No, not yet.
But there is a multiple share screen. I think you try, sir.
Yeah, Shamasa sir, can you stop your share? Okay, it's okay.
Okay, now it's fine. Yeah, please go ahead. Yeah.
Your station?
Yes, now we can see and put in the presentation mode and continue. Mr.
Yeah, now it
Okay.
now it is visible.
Yes, visible in clearly we can hear you, and continue in the presentation mode.
Yeah, thank you so much. My name is Mohammad Nasim Muradi from AMD departments, Afghan Meteorological Department.
Can you put in? Okay, now it's fine. Yes.
It's fine.
Okay, AMD method that use the preparing a warning. Before that, I want to say something about the forecast division. Forecast division is comprised of 4 departments: forecast departments, synoptic departments, upper air departments, aviation departments. And AMD forecast division responsibility provide 3 days weather forecast service for the related government, stakeholder, entities, and end users. And as well as provide sector, the forecast is disseminated our website www.amd.gov.af, and also we share with media and TV also. And for AMD warning method, we are using station data, MedCap plus FFGS flash flood guidance system and satellite. AMD providing 6 weather parameters warning for all 34 provinces, flash flood, heavy rain with snow, extreme temperature, heavy snow, high wind. You know better about the lightning. In Afghanistan, lightning killed and injured more people each year in Afghanistan. During the monsoon season, we have thunderstorm and lightning in the northeast part, south part, and central of the country during the Indian monsoon. And also Black Sea air mass, which enters from west, northwest, and southwest, most effect between October, May, the warm area of the country. We display meteorological warning in 3 colors and 3 languages. You can see no severe weather, be aware possibility, be prepare possibility. And this is our warning reports. This is for flash flood. And also this report populated by 3 languages, Pashto, Dari, and English. And this image you can see the last year flash flood happening in the north part of Afghanistan, in Parwan provinces, killed more than 100 people and injured more than 150 people. And this report is from ANMO reports we received from ANMO. And this report shows the accident, the lightning 32, and death 35, injured 28, life is took 60, total destruction 25. This report is actually I think it is not complete report, because as you know, some part of the country not secure, because it is not the data is not completed. And this is our website. Everybody can access. We have a website on Facebook. Also, we need and challenges: low spatial resolution model, lack of station across the country, lack of coordination between responses agency and other relevant organization.
Mr. Nasim, 5 minutes past. Maybe you can wind up in 30 seconds. Yes. Okay. Continue.
Yeah. Data gaps from 1977 up to 2005, lack of observation and lightning department, lack of research related to lightning department, capacity building, and also we don't have a radar to detect the lightning. Thank you so much.
Okay. Thank you, Mr. Nasim, for a very informative presentation in a very short time on about early warning mechanism in Afghanistan. And
Yeah,
on
thank you
next,
so much.
next we have a country presentation from Bhutan by Mr. Monju Subba from Weather and Climate Service Division of National Center for Hydrology and Meteorology. Mr. Monju Subba, the platform is yours. Please continue.
So the presenter can stop sharing his presentation.
Is Mr. Manju Subba there, present there? Are you available?
I'm not seeing.
If she is not visible, then we can move on to the next presentation.
I think we will move on to the next presentation. Next is on the agenda is country presentation from Maldives. Will be presented by Tahmina Abdul Karim from Maldives Meteorological Service. Tahmina, please continue. Tahmina, I can see your presentation, but I cannot hear your voice.
Now my voice is clear?
Yeah, yes, yeah, continue. Put in full screen, presentation mode.
Yeah. And if possible, you can also switch on your video, please.
I'm trying to switch on the video. Now can you see me and my presentation?
Right.
Yeah, it's both clear.
Okay, thank you, Mr. Ahmad Rashid, co-host and co-chair, and thank you the participants from all over the summer groups. I'm from Maldives and from Maldives Meteorological Service. This presentation is about the status of lightning predictions and practices in the Maldives. The presentation outline mostly cover the lightning climatology and forecast warning of lightning and some of the lightning incidents. You know, Maldives is over the equator and we have very fragile ecosystems, being the lowest country on earth with 1.5 meter above sea level. We have a tropical climate with 2 seasons, northeast and southwest monsoon season. Our average rainfall is around 2000 millimeter per year. And mean maximum temperature is 31 degrees Celsius. Throughout the year, we get rainfall as well as the sunshine. Moving into the lightning climatology, in Maldives, we do not have the lightning data. So thunder days here, this is the chart of thunder days, which was recorded in our 5 meteorological observatories. This data is from 1995 to 2014, that is accumulated monthly thunderstorm occurrences during the 20 years period. So here a thunder day is determined by hearing a single event of thunder or visual observation of lightning. Here we can see that the maximum number of thunderstorms were reported in the northern and central part of the country and the minimum in southern part of the country. April and May have the peak thunderstorms in central and northern part of the country and July in southern part of the country. Thunder days or lightning incidents spread over the period from March to December. The monthly distribution of thunder days closely follow the precipitation patterns in the Maldives. However, the rainfall gradient is from south to north. We have more rain in south and less in north, but lightning or thunderstorms, we have more in north and less in southern part of the country. These data show that the variation of number of thunder days has an increasing trend over the 20 years period. Hanimadu, Kaddu, Kandedu, These three stations have an increase in trend. This is lightning climatology for yearly average number of thunderstorms. Here we can see that northern part of Maldives have average 40 days per year and central 38 days per year. And there is an increase in trend of thunderstorms. The maximum number of thunderstorms occurred in 2008. That was 61 days in Hanimadu. This is a forecast and warning of lightning. We use IMD products, that is insert 3D brightness temperature imageries from IMD website. Actually, this imagery is only covering up to 5 degrees north. So only northern part of the country is covering these imageries. Apart from that, UMETSAT imagery is also used to monitor the lightning activities over the Maldives. Apart from that, recently developed website, this ARMET site, and this website is used for draw the polygons for SIGMET, for issuing SIGMETs. And apart from that, we have AWS network. There are 37 AWS across the country. Through that, we can identify the most raining places. Apart from that, weather radar imageries. And from the radar imageries, we can identify these call lines of severe thunderstorms. And apart from that, there is a Apaya observations carried out in Gain Station in southern part of the country.
With limited time, I think I can give you 1 minute to wind up.
Okay, I will conclude within 1 minute time. This is a forecast and warning of lightning. Here, like many other countries, we also have developed SOPs. Under the SOPs, thunderstorms, we issue white, moderate, and severe thunderstorms, severe alerts for thunderstorms. These three colors are used. Minor, moderate, and severe. For these three, white, orange, and yellow, three colors are used for issuing thunderstorm. This is one of the example of our alert. And this is the list of lightning incidents happened in the Maldives. It shows that many tall buildings were hit by the lightnings during the recent years even.
So time is almost up.
Yeah, and this is some of the lightning incidents photos. These are taken recently. And come to the conclusion, our data shows that the lightning incidents and lightning related power outages in the Maldives is becoming significant. There is an increase in trend over the thunder days in Maldives, which may lead to have a significant impact on the general public and economy of the country in future if proper protection measures are not adopted at this stage. Also, the country is in a rapid process of industrialization. The impact of lightning on the country may also be felt significantly if proper protection measures are not adopted at this stage. It should be noted that the most rural housing structures in the Maldives are made of such that it is vulnerable to fire, sides, flashes, and step potentials in the event of lightning strikes. So our islands are very small and it is scattered. In most of the islands, there are tall objects like antennas. Many times lightning hit on the antennas and cause damages to electric items. So what I believe is it important to have a lightning safety and protection at each of these kind of development. It is important to consider lightning occurrence patterns, type of lightning losses, and regional variation of lightning incidences. So what I need to highlight here is research in the field of lightning is also very important for Maldives. Thank you.
Okay, thank you, Tagumina, for highlighting the requirement and very informative presentation on thunderstorm activities and seasonal variability and climatology of thunderstorm in the Maldives. Next on the agenda is the country presentation from Myanmar. Will be done by Mr. Hugh Lewin Wu from Department of Meteorology and Hydrology. Mr. Hugh Lewin Wu.
Can you hear me?
Yes, I can hear you. And your presentation is on the way. Yes, presentation also can be seen. Okay, continue.
Okay, sorry for our absence in session 3 due to the electricity and network problem. So today, on behalf of Myanmar Department of Meteorology and Hydrology, I will try to review brief about the thunderstorm story in Myanmar. So we this morning we learn a lot from our South Asian and the Indian Ocean neighboring country. We have the seasonal climatological activities or the thunder and lightning activities in different country and different location due to the different topography. So they are a high impact on our each community. So in Myanmar, we our focus are also familiar with this brief calendar about the different hazards in different seasons. So you can see the thunderstorm activity March to October, and hailstorm activity during the pre-monsoon periods. That there are many other the meteorological hazards in different seasons. In based on the bisolar information, lightning density met for Myanmar is 12.3 even per kilometer square per year. So this is not so much comparing with our neighboring country. So we provide daily weather focus 5 times per day, including if we have the thunderstorm, thunder shower, thunder activity slightly in different state and region. And also we provide the coastal weather bulletin once a day for the coastal marina. And especially we provide the segment information, segment warning for our Myanmar, Africa and neighboring country via the EFTL network. When we have the observation of the forecasting of thunderstorm activities and severe turbulence associated thunderstorm weather. And we also issue before the starting the pre-monsoon season, middle March to the May, by bi-weekly thunderstorm advisory and its associated high impact weather for the general public through the media, social media, newspaper, radio, TV also. And in our website, we provide the GFS-based 30-kilometer WR product. And also for the public awareness and public preparedness for the summer season thunderstorm activity, we frequently interview and communicate with our media. At the same time, we receive especially the regularly information and special outlook from the RSMC New Delhi. So please accept our sincere thanks and gratitude to provide this kind of the important advisory information to RSMC New Delhi to neighboring country, including Myanmar. And also, we are trying to provide the thunderstorm information for the segment warning from the provided by Himawari 8 satellite and Sat8 application through web-based information and warning system. We are trying to issue a segment warning among our FIR area. And this is the information we communicate with the state media and then public media for the awareness raising of the thunderstorm activity. So we try to inform the public frequently about the high risk of the thunderstorm, especially the summer season. And also we are trying to closely participate and actively participate among the South Asian region. Last 2 years, we participate in presented this kind of the review of thunderstorm research activity at the Orissa state. So this is
kindly
okay.
try to wind in 1 minute. Thank you.
This is just thunderstorm 30 years climatology study at the Yangon. Same time. One peak in May at onset time and another peak in September. This is Yango. The long-term trend indicates mean annual mean 52 days, but 82, 1982, 26, and 1999 over nearly 80. So diurnal variation also afternoon or evening hour is the highest frequency of ternary days in Myanmar also. So longest duration is most of the thunderstorm activities only just less than 2 hours. This is northern Myanmar area. Northern Myanmar area also 60 to 70, 80 days, some year 100 days to 80 days also. The same present. The converted and the type are also very frequently occur in this area also. This is
Sorry to
interesting.
interrupt again.
Interesting.
We are
This is
running out of time. Can you just
Ajit, and this is Myanmar study very close with 80 days line, very close with our study area. Also here is 60-day line also very close with the 52 line. So we can cooperate for the thunderstorm frequency study, climatological thunderstorm study in our future. So this kind of
Mr. Kiran, I think we also have limited time for the Zoom,
Okay.
so I think we should
Yes,
wind up
this
now.
is
Okay.
this is our presentation. Thank you for your kind
Okay.
cooperation.
Thank you. I'm sorry to interrupt again. Thank you, Mr.
Okay,
Kim
long
Leon,
time no see.
for very informative presentation on the capacity and thunderstorm monitoring and climatology and alerts advisories to different user communities over Myanmar. Next on the agenda is the country presentation from Nepal, will be delivered by Mr. Bikash Nepal and Mr. Chiranjeevi Betwal from Department of Hydrology and Meteorology. Any one of you can continue with the presentation or both together. The floor is yours.
So thank you for this opportunity. Am I audible?
Yes, audible and can be seen.
Okay, so now I will start my presentation. So today, it's me Bikash Nepal, meteorologist working at Department of Hydrology and Meteorology, and this presentation is prepared in conjunction with Chiranjeevi Betwal, meteorologist, same. So now, to begin with my presentation, I have arranged my presentation in this format. I will be discussing on the general feature of lightning over Nepal and its prediction, what we are doing now, in Nepal, and its current status in Nepal. So begin with my presentation. When considering the seasonal variation of the lightning, pre-monsoon season receives the highest lightning stroke among the other months. So here we can see in this graph, April receives the highest strokes compared to other months. And the March, April, May, it is mainly concentrated during this March, April, May season, the lightning event. And now moving toward considering the diurnal variation of the lightning stroke, it is during the around 1200 UTC, 1700 NST, we received the highest frequency of the lightning stroke, and the midnight also it is the second peak of the highest frequency of the lightning strike in the Nepal. And this is the distribution of the cloud to ground and intra-cloud lightning strike. Here we can see the cloud to ground frequency is higher than intra-cloud. And while considering the spatial distribution of the lightning, Himalayan region in the high mountain regions receives less strokes compared to mid-hilly and plain Tarai region, and the lightning strikes are more concentrated over the central part of the country. Now, considering the fatalities of the lightning, this data from our disaster response authority, DRR portal. Here we can see in the last week too, lightning from the lightning we have four fatalities, and comparing the last month, it is thought from fire and animal incident, 7 fatalities were reported, and considering the last year, starting from the yesterday, 69 fatalities were reported, and the fatalities from the overall fatalities from the lightning are thought from the landslides and fire. And here we can see a distribution of the annual variation of the different event and its death. You can see the thunderbolt is the third from the other. And this is the distribution of the district-wise distribution of the lightning fatalities. And here in the Makwanpur district, which lies in the central Nepal, has the highest fatalities compared to other districts. So what we are doing currently in Nepal to predict the lightning. So it's a very huge challenge for us in the topography like our, which is complex and no well-established lightning prediction system currently in Nepal. However, Meteorological Forecasting Division under Department of Hydrology and Meteorology is issuing weather warning, and in that warning we include the lightning and thunderstorm forecast based on the various NWP outputs from our own model, WRF model, which we run in our office, and including other models output from other international NMHS like IMD, PMD, and ECMWF. And MFD also issues SIGMET for Aviation Authority as a nowcast information. And forecasters, another thing we take is the forecasters' intuitive knowledge. That is in the pre-monsoon season, afternoon thunder shower is most common. So that is another basis for the prediction of the lightning over Nepal. And those warnings are shared to national disaster authorities, our home ministry, and to the public via different mediums, public media, social media, email, and public broadcasting media.
So because we have 1 minute remaining, try to wind up.
These are the bulletins. Now, lightning nowcasting over Nepal. We are providing the nowcasting information based on the satellite observation, SNOP and METAR observation, lightning observation network, which we have recently installed, and the radar observation, which is mainly focused on the Western Nepal. We are going to install 2 more radar in the Central and Eastern Nepal. Warning issued via website, social media for general public, and email too. And these are some examples. This is the radar image and the lightning network image. Now, the current status under PPCR project is pilot program under World Bank. 9 lightning detection station has been installed in Nepal. This is the station network, and this is the sensor. And the current linear field antenna receives magnetic waves in the frequency range to 5 to 100 kilohertz, provides real-time information of the lightning occurrence, and provide nowcasting information based on cells tracking. And this is some images of the lightning. And now the NDRRMA, our National Disaster Risk Reduction and Management Authority, is creating awareness, public awareness via this visual information, visual videos. And DSM is working in close coordination with the NDRRMA. Now, the challenges in our lightning prediction and nowcasting is our complex terrain one, weather models not able to detect convective system very well, recurring technical issues, and the limited manpower. Now, the summary, pre-monsoon season is the highest pre-monsoon season, and afternoon time receives highest lightning strokes. Fatalities from lightning are thought, and no well-established lightning. MFD DSM is issuing weather warning, including warning for lightning. Recently installed lightning observation network over Nepal, capable of real-time observation, nowcasting up to 2 hours. NDRRMA is raising public awareness via visual information via social medias. Thank you.
Okay, thank you, Mr. Vikas Nepali, for a very informative presentation on general status, features of lightning and thunderstorm activities, its distribution and impact, and current status, and your efforts to improve the warning over Nepal. Next on the agenda is the country presentation from Pakistan, will be delivered by Dr. Zahir Ahmad Babar, Director, National Weather Forecasting Center in Islamabad, Pakistan Meteorological Department. Dr. Zahir Ahmad Babar.
Thank you very much. I'm Zahir Ahmad Babar from Pakistan Meteorological Department, Director at National Weather Forecasting Center. I hope you can see my screen and hear my voice clearly. So yes. I will try to be very quick because I will be the last person between you and your lunches, I think. So let me start with the sequence. This is the sequence of my presentation flashed in front of you people. In Pakistan, we have a very peculiar weather systems coming in because we have a very strange location. In summer, we have the monsoons coming from the east, from the India, and then in the winter season, we have the frontal weather systems coming from Iran and Afghanistan and entering into Pakistan. So these two different weather systems affect Pakistan, and they produce thunderstorms and all those related activities in the country. We have a list of hydrometeorological hazards which are related with monsoon, post-monsoon, winter, and pre-monsoon seasons. In monsoon is the most of the heaviest activities. We have heavy rains and flooding, and both urban flooding as well as flash flooding accompanied with thunderstorms and lightning. So obviously, when there is no rain, then we are facing the drought seasons. Similarly, for the post-monsoon season and the pre-monsoon season, there are a variety of hydrometeorological hazards which we are facing. The lightning thing has become very relevant to Pakistan as well, because I have flashing two news reports in front of you. One is from 2020, in which Sindh faced, particularly one of our most populated cities of Karachi, faced very heavy rainfall in the monsoon season, and in that the lightning struck and killed 4 people. And before that, usually in November, usually lightning does not occur, but in 2019, lightning struck and there were 18 casualties in that one single episode. So that frequency of lightning is very much there, and it's increasing and different seasons as well. The spatial distribution, as most of the speakers have mentioned, that it is beyond 30 degrees. And if you can see between 1961 and 1990, the thunderstorm activity is mostly concentrated in northeastern parts of the country. And this frequency was a little bit less between 1991 and 2020, according to one of the studies. But the study conducted for the region between 2000 and 2014 suggests that the thunderstorm activity is still there, persistent in the northeastern parts of the country and parts of the Bangladesh as well. For the seasonal distribution, we can see that the big bars, which are the holographs, they are for the monsoon season, and the horizontal lines, which are thick lines from going from top to bottom, are the pre-monsoon season. So most of this seasonality of the thunderstorm and lightning activity is in between the monsoon season and in the pre-monsoon season for all the trading units of Pakistan between Khyber Pakhtunkhwa, Punjab, Kashmir, and Balochistan. So they all have the common that most of the lightning and thunderstorm activity is between the monsoon and the pre-monsoon seasons. And for the seasonal distribution, we can see that between 2000 and 2014, according to a study by Saha, that most of the activity is between June to September in the northeast parts of the country. And strangely enough, as one of the studies has also mentioned, that the post-monsoon season, the thunderstorm activity is also increasing in the post-monsoon season. And regarding the trend, a decreasing trend was observed between 1991 and 2000, and it was almost 5.3%. But during 2000 and 2014, there is no significant change in the LFR, lightning frequency rate. So this means that it has become steady in the northeastern parts, or the parts which are being affected by thunderstorm parts in the country. Most of the studies, they show the causes, those causes of high flash density is because of the orographic barriers. And some of the studies suggest that it's because of the local heat and advection and fractional convergences, and they all contribute to the triggering deep convections which are taking place during the monsoons and the pre-monsoon seasons over Pakistan.
Dr. Zahid, try to come in 1 minute.
Yeah, sure. I'm very quick. And there's one study which suggests that the El Nino period has the most intense lightning activity than the La Nina period. So we can conclude that in the northern Khyber Pakhtunkhwa, that the northern parts of Pakistan, which contribute of Kashmir and northeastern parts of Punjab, they share about 65% of total thunderstorm activity. And in Pakistan, second or third day, or every third or fourth day, have the monsoon is the thunderstorm day during the monsoon and the pre-monsoon seasons. And as I've discussed earlier, the net decrease of 5.3% in 1991 and 2000, but it's almost the same between 2000 and 2014. And these are the some of the references. Thank you very much.
Thank you, Dr. Zahir, finishing on time. It is very informative presentation on hydrometeorological hazards, impacts and thunderstorms and lightning and spatial distribution over Pakistan. If we could not get some presenters from Bhutan, is Miss Manju Sabha present? If she is there, I think we can give 5 minutes. Otherwise, I will hand over to my colleague, Mr. Sunil Karavasan from Sri Lanka, to carry forward with the rest of presentations on this session. I thank all the country-specific presenters for their very informative presentations delivered. Mr. Sunil Karavasan, please carry on. Thank you.
Thank you. Thank you very much, Mr. Ahmed, and your effort to manage the time, especially, now we all are looking forward time for lunch, because, we all have passed our lunch time. So now I think now we can proceed for the next two remarks by our colleagues, Dr. Gulam from ICIMOD. Shall we invite him to present or make his remarks on this program?
Thank you, Chair. Thank you. Am I audible?
Yes, sir.
Okay. Very good afternoon, Sama community. And my sincere gratitude to Professor Das and Professor Ajit Tyagi. This is a commendable initiative at this stage when lightning is occurring in South Asian region. This is really a wonderful opportunity. Many of the scientists have presented their research work, and we have seen a lot of things are going on. And there is a strong capacity of this region in thunderstorm and lightning detection. At ICIMOD, we have also developed a tool, high impact weather assessment tool, which is backed by multimodal ensemble. And this is coupled with geospatial information technology. We call it HiWatt. Dr. Abdul Manan from Bangladesh has presented some results. We are now in the phase of validation, and soon after completion of that validation, we will be sharing with the interested member countries, and hopefully in mountainous region especially, because we have addressed orography and convection both at the same level. So I would like to thank again the organizers of this webinar, which is very, very useful. Professor Das, you have to conduct some diagnostic analysis. You have heard about the capacity of our member countries. Where there is a gap, how can we fill that gap? How can we improve their capacity? I think that exercise is direly needed. And then at some stage, we can arrange some training modules in which that capacity can be addressed. So thank you very much. Congratulations to all speakers, chairs and co-chairs of the sessions, and our seniors, Professor Rathore and Karmakar, Professor Aryal from Nepal. So many thanks for joining this webinar. And I congratulate this initiative will, I think, continue with innovative ideas that selecting topics of our real interest and addressing, sharing knowledge and addressing the issues relevant to those important topics. So thank you very much.
Thank you very much, Dr. Dr. Gulam, for your remarks. In fact, that gives some direction to the SAMA, for which, for the development of meteorology, and these activities are going on in this our region. So, may I invite our next next speaker from RIMES, our Dr. Srini from RIMES, to make his remarks.
Unfortunately, Dr. Srini will not be available because he had some other engagement, he said. So, the remarks from Dr. Ghulam Rasool is the last remark. Okay.
So then, which means the remarks, now it's over. Now, I'm thanking all the organizations and all organizers and all the our participants, and as well as our presenters for everything to make this event success. And I'm handing over to the Dr. Somesh for the final, the remarks, so the to conclude the sessions. Thanks.
Somesh sir, we can have group photo if everybody turns on their video.
Oh yeah, I think that's a good proposal. So first, let's have the group photo, right? Well, let me thank the two co-chairs of this session, Mr. Sunil Karyavasam from Sri Lanka and Mr. Ahmad Rashid from Maldives for conducting this session very smoothly and almost on time. Of course, overall we are late, but thank you very much for conducting the last session smoothly. Yeah, let's have a group photo, and then after that we'll have the final vote of thanks. Can all of us please switch on our video? Yes, great. Taking a screenshot. Professor Lakshmi Kumar.
Hello, I am not coming into the picture. I think there is something, some problem in my video. I'm sorry. Let me.
Your name is visible.
So it is not coming.
Just 1 minute, so we are taking just, give us 1 more minute time.
I think few people are coming now, so just for 30 seconds extra.
Okay.
Anybody is there? Can switch on the camera.
Now I think I am here.
Yeah, great. No, good.
Thank you.
Is that okay, Professor Lakshmi Kumar? I think
Swagata, you have taken. I also have taken a few.
No, I didn't take.
All the 3 screens, right? I think there are 3 screens or more.
Yeah, two screens are available. Yeah, yes, I have taken. Yes.
So
But
is that okay?
One moment. Rasool sir was here, and few people just switched off. Yeah.
Put on your video, Ghulam Rasool Sahab.
And that from Nepal, Siba PD. Pramod, you could on your camera.
Yes.
Mohan. Okay, I think this is sufficient.
Mohan is lost.
Yeah, he is busy with other program.
Yeah. And I was also in that program also for 2 minutes.
Yeah, I took the screenshots. Yes.
Okay.
Thank you.
So, shall we go ahead?
Yes, sir. Yes, sir. Please.
Okay, great. Well,
thank you.
Thank you very much, all. We have come to the end of the session, and now I have this pleasant task to offer the vote of thanks esteemed members of SAMA, distinguished speakers and participants. It is my pleasant duty to offer the vote of thanks. At the outset, we would like to thank the SRM Institute of Science and Technology for their generous support by providing their Zoom platform for conducting this webinar. It is now established that lightning and strong wind speeds associated with the severe thunderstorms is the biggest killer annually over the southeastern region. The number of casualties due to severe thunderstorms are more than the cyclones. The number of casualties due to cyclones have reduced in the recent years due to improvements in our observation technologies, the skill of forecasting and warning system involving numerical weather prediction models. But the lightnings and thunderstorms are short-lived compared to cyclones and occur many times more per year. Its skill of predictability is also less compared to the other weather-related disasters. As the accumulated casualties and damages per year due to severe thunderstorms and lightning are more than the cyclones, which have longer life and provide sufficient time for evacuation and disaster mitigation. I would like to thank AVM Professor Ajit Tyagi, former Director General of India Meteorological Department, who is the main brain behind the formation of SAMA. Would like to express our gratitude for his constant guidance and motivation in all the activities of SAMA. I'd like to thank today's keynote speaker, Colonel Sanjay Srivastava, for presenting a very interesting talk on lightning resilience. Would like to thank all the speakers from India, Bangladesh, Nepal, and Sri Lanka for presenting the state-of-the-art technology on lightning resilience, climatology, and prediction over the southeastern region. Would also like to thank the speakers from Afghanistan, Bhutan, Maldives, Myanmar, and Pakistan for presenting the lightning prediction and practices in their respective countries. We are aware that some of our neighboring countries are lagging behind in the lightning prediction skills, but SAMA can arrange training workshops on capacity building for enhancing their skills on lightning predictions and preparedness. Some of the countries in our region have very good ground network of lightning detectors. If we can share and combine the lightning flash rates observed from the lightning detectors in the region, we can make a very good database of the lightning flash rate density. This can be combined with the satellite observations, radar reflectivity, and high resolution NWP model products using rapid cycle data assimilation to increase the skill of lightning prediction. Assimilation of lightning flash rate is another very hot area of research. There is a need to assimilate the lightning flash rate data in the NWP models in the real time, which could substantially improve our skills of lightning warning system. Would like to thank all the co-chairs for conducting these sessions very smoothly. We are grateful to them for agreeing to co-chair the session at a very short notice, despite their busy schedule. Especially, I'm grateful to Professor Deepak Aryal from Tribhuvan University, whom I requested just last night to co-chair the session. Would also like to thank Dr. Ghulam Rasool from ICIMOD for presenting a very nice remark, a concluding remark. Unfortunately, Dr. Srinivasan could not be present, so we could not have the remarks from the RIMES. Would like to thank the members of executive support team of SAMA, Professor P.V. Lakshmi Kumar of SRM Institute of Science and Technology, India, Dr. Mohan Kumar Das of Noami, Bangladesh, Dr. Swagata Paira of VIT, Jaipur, India, Professor P.D.S. Raju of University, India, Dr. Fatima Akhtar of Dhaka University, Bangladesh, for their hard work and coordinating the activities successfully, without which it would have been difficult to organize this webinar. I'm glad to see that approximately 75 people attended this webinar on the Zoom platform, and about 31 people attended this on the YouTube. So more than 100 people attended this webinar, including both Zoom platform as well as the YouTube channel. Also, I could see that many students and research scholars also participated. I'm sure that such webinars provide good opportunity to our young generation to listen to the experts in the field and motivate them to work further in this subject. I thank all for making this program a grand success. Thank you very much. So with this, we have come to the end of the session. Tyagi sir would like to say the last word. Tyagi sir, your mic is mute. Tyagi sir, yeah, your mic is
Okay,
mute.
sure. You are the last one. You are the first one. So I'm thankful to entire ESC team led by you.
Department and Dr. Sam Loyan and
Sir, somebody raised their hand.
Thank you so much, Dr. Dos.
There is some Dr. Kamal, he raised his hand.
Please,
yeah.
Dr. Kamal, most welcome.
Okay, okay. Thank you so much for giving me the opportunity. We are very at the end of the webinar. I was from the beginning. This is Dr. Mohammad Shah Kamal Khan, working as Project Director for Agrometeorological Information System Development Project under Bangladesh Weather and Climate Services Regional Project Component C, funded by World Bank. So it was my great pleasure to participate in such a crucial webinar today, organized by Sama. And I have some observation and suggestion if you give me a few times. Number one is, lightning and thunderstorm is quite different from each other. I know in a brief, if I say lightning occurs in air due to friction of anion and cations, I will not go to in details, but the thunderstorm occurs in the field or ground. So in respect of damage, I should say thunderstorm is harmful for the human and the animal life and for the earth. So these two things should be much more clear in separate topics, maybe difference between the thunderstorm and lightning and its harmful effect and the steps for the overcome. And another thing is that so many topics have been included in this webinar, and there is no scope to discussion with the presenters after his completion. So my suggestion is that the topics may be limited, and if it is not possible to discuss with each presenter, but it may be done with country-wise. Say after discussion with the Bangladesh team's presentation, we can a few times for the Bangladesh aspects discussion. The recommendations and the few aspects maybe kind of that would be very fruitful for all. And another minor request to provide the PowerPoint presentations today to all the participants' email so that we can take documents and pictures that has been presented. And another request, we are participating in a Zoom platform in this webinar. If an e-certificate is issued to all the participants as a recognition that may be our reward for participation in this webinar, that would be a proof or evidence, and it will be encouraging for the participants. So another thing is that the lightning is very threat for the for our Bangladesh aspect, and we the project is also working for that. Our ex-project director Dr. Mazharul Aziz has already mentioned that we are under this project we are going to introduce this early warning system for the lightning in our country under this project. So in this aspect, our ex-expert Dr. Novanshu is connected with Zoom, and he is very supportive to us. He is supported already, and still now he is supporting with us. And in future, we may be welcome to our Indian art organization. I have not mentioned here. Maybe contribute for this installation of the early warning systems for lightning in our country. That would be very fruitfully. Thank you thank you, the organization, the host, to give me this opportunity at very end position of this webinar. Thank you so much.
Thank you, Dr. Kamal, for your valuable suggestions, and we put on your suggestions very well. Unfortunately, of course, because of the lack of the time, we couldn't have interactive sessions between the audience and the speakers. But I could see that in the chat box, there were live interaction. People were raising questions in the chat box, and the speakers were replying to those questions. I'd also like to say that the entire video recording of the webinar will be available on our YouTube channels, so anybody can watch after this is over. We'll try to procure the PowerPoints presented by the speakers, and if it is available, then we'll share with the participants afterwards. So thank you very much once again for your participation and the presence. I know that it's too late, everybody getting hungry, so we have to close the session. Thanks, sir.
Thank you, Dr. Das. Thank you, Dr. Tyagi. Thank you very much from my side. And also thank you, Dr. Shah Kamal, because I was introduced today because we are working in the same project of BMD. Okay, I'm the deputy team leader of MSSI team. Okay, so it is good that you are in place of Dr. Mazharul. Thank you very much. And thanks everybody, and thank all the organizing persons and professors, especially Shagato. He was doing very good also, Shagato. And yeah, I have seen some other persons of Maldives where, and one thing is that one of my friend already forgot me. He is here, Dr. Abhay Singh. How are you? Dr. Abhay Singh, do you recognize me? Hello?
His mic is mute.
Mic is mute. Because we work
No, only
together.
Abhay Srivastava present. There is no Abhay
No,
Singh.
he's there. He's there.
No. Hawaii Singh is also there.
He's mute.
Was there.
Yeah, now he's not there.
Okay, thank you very much. Thanks everybody, and Lakshmi Kumar also.
No, he's mute. He's trying to say something.
He's muted.
Yeah.
Dr. Abhay Singh, do you remember me?
Yes, I can remember very well. And thank you very much.
After a long time. After a long time. Okay, we'll see you again.
Yeah, see you again. Now
Thank you very much for participation. Thank you.
Thank you, everyone. So let's say bye.
Bye. Bye.
Thank you all. Thank you all.
Thank you very much.
Thank you so much.
Thank you. Thank you.
Thank you all for being here. Thank you.
We could provide a
Thank you, everybody.
where all could share this platform, and thanks to the organizers.
So, yeah. Professor Lakshmi Kumar, we can end the session.
Yes, sir. So I'm closing. I think host can close the session. Host is Praswagata now.
Okay.
You have to end the session.
Close.